Okay, not gonna lie, and I have proof of this. I thought I was live 5 minutes ago. It every light in here turns on like even when I'm not technically live. Um, and I just thought I was live for some reason. Well, no, I clicked the go live on my OBS, right? Like so I have two go live buttons. I've talked about this before. I swear that one time though, I just clicked the one button and then I was live. But maybe it's because I set up the stream differently. I think when it's a scheduled stream, like this is a scheduled one, I have to click go live. But maybe if like I set up the stream ad hoc, like I've already clicked go live. And so then it's just waiting for input from my OBS. Anyway, sorry about that. I have proof, by the way. I really was live 5 minutes ago. Like my setup was all on. So sorry. I'll try to stop doing that. I think I do that every week. Yeah, see, there we go. That's good proof, Hassan. Anyway, I feel stupid. I did my whole intro to it's recorded, but no viewers. Anyway, so yeah, I was just saying, I'm kind of interested in the name. This feels like a crazy name to give a paper that doesn't seem to be about optimizers. Um, but anyway, it's the number one paper of the week. We always look at the number one paper of the week, so I was just saying we're gonna look at it either way. But I'm also very curious, like, what made them think they could use that name. Grandmaster level in competitive programming. Um, why not? It's not actually from last week, but it kind of is. Well, we can look at that one. Man, but all this agentic stuff. Maybe I should get into it. It just like something about it. I'm sort of just waiting until some library really pops off. I mean, I guess if I meant that, I would just use this, right? How many stars does this one have? I shouldn't say I'm waiting for a library to pop off. Meanwhile, OpenClaw is at like 356,000 stars. I don't know what I'm waiting for. Um, to be fair, I've never been like to some extent I view the Clawbot as like within the purview of home automation enthusiasts or people that have like Plex servers, and that's never really been my thing. So maybe that's why I'm not into it. I don't know. Oh, I also just noticed maybe this is staff or something because this is submitted by the same person, but that could just be like Hugging Face staff or something, right? There's no way that these aren't even the same institutions, right? DreamX, yeah, this is DreamX team, and these are just a bunch of schools and then some company. So yeah, must be staff. See, Taste Siri, but yeah. Anyway, wow, so much claw. Uh, what's a code world model? I'm interested in world model, so I should maybe want to know what they mean by code world model. Okay, and an MME follow-up, I guess. This is actually a benchmark that I use in some of my papers, so I wonder if this follow-up is from the video MME folks. It's always kind of funny when a V2 comes from people that didn't do the V1. It feels a little presumptive, right? It's um, like, Ford releases the Mustang and then Chevy comes out with the Mustang 2.0. That would be pretty funny. Or is that an internationally coded what's a better example? Oh, it's like if Boeing released an A400 or something. Like what would that even that doesn't make sense. I think that last metaphor may have had an even smaller target audience than the first one, so I think I'm just moving backwards. Lots of agentic. It's interesting. I feel like in general when we've been doing this, it's been like a lot of vision. It's been a lot of multimodal. And obviously there's been agents, there's been code, but this week especially the top feels like code, code, code. I say that as I like see another video one, but still like lots of code, lots of agents. Okay, I said that and now we're getting to like, oh, from Tencent, from Hunyuan. KV compression. I need to know KV compression. Have any of y'all used Gemma this week? Did we talk since Gemma came out? When was the Gemma release? Was that this week or was that like the end of last week? I guess technically it was out by the time we had the last stream. But had any of you used it by then? I used it this week. It's crazy. I feel like it's noticeably better for what I was trying to do at least than Tongi was. But Good old Qianwen. Oh yeah, by the way, I will okay. Sometimes I'll call it Quen. A little more often than I'll call it Quen, I'll call it Qwen. Um, a little bit more often than I call it Qwen, I'll call it Qianwen. And then lately I like calling it its name, which is Tongyi. But yeah, so if I say any of those things, I'm just talking about what you probably call Quen. So let's see. I don't know about the stars. I've heard Hermes Agent. Oh, Hermes. I've never heard of Hermes Agent. See, I'm telling you the truth, Hassan, when I say I'm not really into the agents thing. Okay. Uh, it's younger though, right? I'm seeing last month as being maybe like the first release, right? 65K stars. Can we get a stars graph over time? Because Clawbot's older than that, right? And that would be part of how it'd be more popular. Where can we see the date? I guess we can see the releases, right? 65K is pretty crazy if it's actually a month old. Like, that's bonkers. Can we see the first release? I don't know if this is the first release. It kind of looks like it. Whereas, I mean, here we probably need to go all the way down to here, right? And then when did this come out? Oh, I mean, not too much longer ago, but like 5 months is obviously different than 1 month. 65K is a lot of stars. I'm surprised I haven't heard of it. But again, check this out. Check me out. I'm gonna go onto my main monitor, or not my main monitor, my main browser. Look at me. Proud of myself. Check that out. Boom. I'm not lying. I'm not logged in. Haven't been logged in all week. So I'm a little out of like that loop. I'm still in the LinkedIn loop though, so I'm kind of surprised I missed something with 65K stars. Especially because I have a lot of coworkers that are like really into the whole agentic engineering thing. But maybe Hermes is more about some of like the personal assistant stuff, right? And that's not agentic engineering necessarily. Although I'm not going to speak to it too much because I really haven't looked. Maybe if I looked closer, it is. I did see when we were going through the releases, they were advertising a lot of the messaging functionality. So I'm assuming it focuses a bit more on that. Okay, streaming video understanding. This is cool. I just submitted a paper for streaming video understanding, and I don't love a lot of the benchmarks for streaming video understanding. So always interested in a different one. Paraphrase robustness in VLA models. Is this just saying like when we give the prompt, how much do they struggle with the shorter prompts? That would depend on your. I want to see what that is. Thinking strokes, not pixels. Process driven. Sure, interleaved reasoning, I guess. AI at Meta. Probably an intern paper, but we can see. Have we talked about this before? This funny trend where people are like, the new Google paper says, or the new Apple paper says, or like you'll go on LinkedIn and they'll be acting like the whole strategy of the company is this one paper, and then you look at the paper and it's like somebody's intern project. That's kind of funny, right? I think it's kind of funny. Like I'm pretty sure. No, that's not a good example. Hold on, I'm trying to think of a. Yeah, I can't think of one top of mind. So maybe one of you can think of one, or we'll come across one, and then I can mention it again. But I feel like this happens a lot. People are like, Apple says this about LLMs, and it's literally just like an intern that worked, 3 months at Apple and wrote a paper. Probably most of that paper they wrote while they weren't even at Apple, right? But people literally act like the thing is Apple PR, which so I kind of get it. As a PhD student, you're really grouchy when the company wants to block your paper or when they ask for changes. But people like, especially normies, are treating this like literally the main public signal of what the company wants to do with the thing strategically. So kind of makes sense that they want to have some control over how you present it. The press doesn't pay attention to that little asterisk you put, work done at internship, or to the number that says your main affiliation. Sorry, my ringer was on for whatever reason. I haven't been clicking a lot of papers, but nothing is really catching my eye. Have I been missing something? Ooh. Have I been missing something I should have seen? Noisy supervision. You know what I've been getting really into this week is scaling laws. Like before, I feel like my understanding and grasp of scaling law was very tenuous. But it's becoming, and very like hand wavy, sort of just like, oh yes, bigger model, bigger data, better. Like, but lately I've been getting into like the power lines paper and a few other things, trying to understand it better. Maybe we should talk about that at some point because it's on my mind a lot right now. Enabling autoregressive models multi-token generation. Sure, why not? Okay, I'm probably biting off more than I can chew here. We need to find that here. Here's this top paper I said I read first. Anybody got some of the papers they want me to look at? Feel free to put them in the chat. Yeah, Video MME, thanks. Hassan, we got that one open. I don't know about, okay. Hi, Matt, trying to follow your paper about R nerves and making my own. Any tips? It depends on what you're looking for, broadcaster. Like, if you're looking to be some kind of state-of-the-art in video INR, one thing that you need to be aware of, like a really important thing, especially if you're trying to submit papers and saying that video INR can do compression, you really need to care about this paper that is not INR, because for a long time, there were really like two main ways that would come to people's minds for doing video compression with neural nets, and that was like taking some part of the existing pipeline and just replacing it with some like drop-in neural thing. The other way would be to replace it with this like autoencoder like structure. Yeah, this kind of shows it here. Okay, encoder decoder, right? This is an autoencoder. Those were like the two main ways. When I say the two main ways, really neither of them were the main ways, right? Like state-of-the-art codecs were still releasing with no neural components at all. The ones that you dropped into the pipeline weren't really worth the trouble. And the autoencoder based methods were slow. And when I say slow, I mean like less than 1 FPS slow. To where I think I actually had an argument with, can't remember which of these authors. I had an argument with one of them at the conference, not this paper, but the paper before it, because they were calling it like realistic compression. It was like 0.5 FPS or like 0.1 FPS. And they're like, that's just an engineering problem. And I'm like, no, that's a research problem. And I feel validated because lo and behold, it's solved in a research paper, not an engineering paper, right? And it's solved by changing the algorithm, not by just random optimizations and hacks. So, but the thing is, for a long time, when I submitted a paper for video INR compression, and people would point to this, I would just be like, well, there's lots of ways, like, basically the video INR would be slow encoding, but fast decoding. And this would be like decent encoding, but very, very, very slow decoding. So I could point to that and be like, it's an even less realistic paradigm, right? Because sometimes you could tolerate long encoding as long as the decoding's fine. Maybe it's like a movie. You just encode it one time. It doesn't matter, right? But you can never tolerate slow decoding. There's literally no application for it. So that would be kind of the argument that I'd make back when they had slow decoding. And also the quality wasn't always matching, VTM. But then this paper came out, and it's real-time decoding. And let's see if we can find a bitrate plot. Does this compare to like a good baseline? Let's just find where they compare to the VTM. Here it is. VTM is the black, and then DCVCRT is the red. Oh, look, now we're smaller and higher quality than the VTM while also supporting real-time encoding, real-time decoding, right? So now submitting papers for video INR compression is really tricky because you have to find a reviewer that really buys the idea that it's worthwhile for you to just push forward within that paradigm, even though there are other neural approaches like this that are strictly better on practically every axis. So the thing that I did, I actually am still submitting papers in this area with like mentees, although I think we might try to kind of pivot out of it. But we do try to sell the whole, this was a method that had really slow encoding, decoding for a really long time. And they got to iterate on it. And, they made it faster until, their last thing that they did was make it really fast. And I'm like, just give us that time, right? Give us a couple years the way that they did. Like, this line of work started a little earlier than nerves. But that's tricky to sell reviewers on, right? So it's just something you have to be aware of. So one direction, though, that a lot of these papers actually still go in is if you look at like NVRC, I'm just going to make sure I give you enough search terms, right? Like, I guess this isn't that recent anymore. But a lot of these video INR folks will actually just go in the direction of like, let's really, really push the quality size trade-off. And here, where can we find, like, here, see NVRC is the red? The red, I'll zoom in more for you. Okay, so this paper is compared to a lot of the DCVCs, not DCVCRT, obviously, but it's basically better than everything except the random access VTM. And I guess it's still worse than the, okay, so still worse than the DCVC, even the slow one. But basically what these lines of works would try to do is they would just make the encoding, the training even slower to try to get to the point where they could make quality arguments on certain data sets. I don't know if it's worth, though, just continuing to push a direction that requires too much encoding time to ever be practical. Anyway, I'm kind of going off on this crazy tangent with implicit neural representation now that probably nobody cares about except me and maybe Dub Broadcaster. Um, so I guess my tip would be just really make sure that you have that bigger picture in mind. Like why are you still chasing INR as opposed for going for something else? I think something that we should do, referring to me and any mentees I have, if we do stay in this space, is really focus on the unique advantages of the INR, right? Like, I'm not going to fully explain this, but um, the INR, the way that it works, it supports in-painting, it supports out-painting. It also basically supports, uh, pretty naively, this idea of any resolution inference. With the same model, you can perform the inference at any resolution. And that's kind of a cool idea. Like you can have one encoding that, depending on the exact ways that you design that one encoding is actually all your sizes at once, which is kind of neat. So I think part of what you could do too is just focus in on like what are the unique advantages. I also think if I'm going to get really specific, giving you advice around RNerve, like something I was noticing with RNerve is it seemed like there were two different ideas for how to encode the video, right? One of the ideas was our HNerve idea, which was like have an encoder learn some like video specific feature. The other idea was to just have an even better kind of fixed position encoding with grids. And based on all my experiments, I think grids are strictly better. But obviously it's even slower. So I think if you could actually get grids to work within the HyperNet setup, um, like this paper, here, I don't know what he ended up calling it, so I'm going to put all these in. Like, if you can get hypernets to work, like with this paper, but with a more optimized INR hyponet, using like a grid representation, maybe you can get the quality high enough. I also think something you could do is you could take some of the learnings from RNerve and take them over to the hypernets, and like the hypernet encodes so quickly, you have a little bit of leftover time. You can maybe afford like some learning step, like a very fast learning step on the video itself maybe, and like refine the representation a little bit, because like sometimes you get the video out with like still like you maybe come up 120 fps, whereas it would be totally tolerable to encode it like for streaming 60 fps, but for longer video, if it's quality, you could encode it like 5 fps. So maybe you could do some learning steps and really push that setting where it's the hybrid between like the hypernet predicts initial weights and then you very, very quickly refine them. So, really leaning into the whole meta learning. Those would be like my high level advices. Anyway, sorry, I went really hard on that little tangent, but that is obviously like the area I spend a lot of my PhD. So it's something I like talking about. Anyway, you should review some old papers, including something from implicit neural representation. I could go over some just like older thing. Some older thing that I like. Virtual try-on paper, Hassan? Let's see. Yeah, we could do virtual try-on. Where was it? Do you remember the name? I'm looking for it. Oh, here it is, right? Yeah, there we go. Here, you requested Hassan virtual try-on and you requested video MME, so let's do those first. Any other viewer requests before I really get going? What do you think on the future of meta learning? I don't know what to think on the future of meta learning. It depends on which like subfield you're talking about, right? Do I think we're ever going to meta learn big models like, do I think meta learning is going to have any meaningful role in our video generative model pre-training or our LLM pre-training? It's hard to imagine what that would look like. I think where it could have value, though, is in personalization. Like maybe personalization of that network could look like a LoRa, and maybe instead of training that LoRa could be predicted by a hyper network. It could be meta learned. I don't know. If you have a user embedding, you could jointly pass that through some network that would predict the matrices you need to modulate the core LLM to get outputs that are like slightly more tuned to the user. Because I'd have to imagine that like a slight, like there would be a space where the LLM naturally gives outputs that are a bit better suited to you. And maybe it's pretty close to whatever the optimal final solution is. But I'm not an LLM person. Maybe that idea is totally ridiculous. I don't know. Hi, Matt. Hi, Matt. Hi, Matt. Hi, Ifta. Hi, Lone. I'm really curious about what you're doing about foundation models at your job. Is it related to video compression? No, Lone. I think I can say this because I think it's here. Let me go to the website and see what's kind of obvious from the website. I should be careful. Um, and speak on things that are okay to speak on. Shaping the future of AI. What does this make it look like I do? We create world-class foundation models that redefine what AI can do, globally impactful, scientifically rigorous, and open for collaboration. Advancing responsible real-world generative AI research. View our models. I work on the follow-up to this. So I'm training big models from scratch. That's what I do, Lone. I think I can say that. Hopefully I can say that. If not, I'll get in like a little trouble. But I think we want people to know that that's what we do. So and I'll learn more about like what exactly I'm supposed to be saying and allowed to say as I spend more time at the company. We're actually, check this out. This is pretty cool. Again, don't know if I'm allowed to say this, but it's publicly facing info. I'm just signal boosting it. So CVPR, check this out. Sponsors, ultimate tier. Look at us. Check that out. Ba-boom. Ultimate tier. That's pretty cool now. Ultimate tier CVPR sponsors. So, pending anything crazy, I'll be at CVPR. If you're at CVPR, feel free to come say hi at the IFM booth. I should be spending some time there at least during the expo. I don't know how long. I assume I'll want to go see posters some of the time too. Some of us will be at that booth though, all the time, like the whole time the expo is going on. So come say hi. We had a guy start 2 weeks ago, and he told me he'd seen a couple videos. That was my first time meeting like a viewer that didn't already know me in real life, which is kind of trippy. Especially because like my audience is not huge, right? But again, it's like a niche, so like my odds of meeting someone in my audience are pretty high. And he was like the almost what I view as like the target audience, where like he had just finished his bachelor's like a year ago, right? And so that's totally like the sweet spot of where I expect my content to be sort of going. You know, people that are in that transition, like late undergrad, early PhD kind of. Anyway, okay, let's do a couple papers. I feel like I'm taking way too long to get to this. Let me check my OBS real quick. I do want to do the vertical crop real quick, so bear with me. I'm just taking some measurements. Every format's a little different, which is okay. See, like this one, for example, we can definitely do it at 90. Nope, we can probably do it at 95. Yep, definitely. Okay. And then this one, we can also do, I believe, at 95. That's weird. What is this format? Anybody know this format? Because I cannot do CVP. This is definitely not CVPR. CVPR is 85% for me. Whereas this one, 95 is just fine. But it's double column. What is it? Also, are we getting more agent papers because there's some conference coming up where that would make sense? Feel free to let me know. Anyway, let's get my clock real quick. Let's get my timer up. And let's get my notes up. And let's do a couple papers. And then I'll answer some more questions. But if I don't do papers now, I'm just never going to start. And that's not good. Okay, let's get this over here. Let's zoom in on the resolution. Okay. I'm almost done with my coffee too. So I'm starting to get kind of like drinking it too fast. I meant to like spread it out a bit more. Anyway. What were you doing at TikTok? Not asking the private stuff. Great question, Hassan. Let's talk about that after a couple papers. Okay. Virtual try-on with human image animation via synthetic triplet supervision. So we're going to be given a human image and some garment images and generate the try-on. Yeah, that's the task, right? So try to show what the clothes will look like on the person. The key here is you obviously don't want it to look like in my MS Paint, I just pasted the shirt on the person, right? We're trying to see like how the garment naturally fits on like a real human body. Where are like the creases? How far does it come down? What does it look on the arm? Stuff like that, right? And the tricky thing is, if you generate a plausible thing that might be true but isn't true of the garment, you've lied to the customer. So the accuracy is pretty important. Conventional two-stage pipelines treat image-based virtual try-on and pose-driven animation as separate processes, which often results in identity drift. So their model addresses the issue by performing the entire process in a single step. Okay, so they're trying to do both like the main image and like all the poses in one step as opposed to two to try to make sure that they're all kind of unified, which makes sense. But that doesn't exactly tell us the solution. How are they accomplishing that? I should have been faster. I spent too long explaining what garment try-on is. Here, let's zoom in though. The fonts are just tiny. Train only supervision on just a few different poses of a garment. We estimate the key points to get the pose video. We get some human image generation. Like I guess eye to eye, basically. Condition all these images. We generate like a neutral image of the person. We encode the pose and the image both with a VAE that encodes pose and human tokens. That goes through a human animation module. The DIT itself gets actually, okay, the generated human image is just going through the human animation. Oh, because this is like the generated human image for the animation specifically. Okay, so like we generate an image that's going to be animated along with the like some kind of like starting pose, or we estimate the pose in the video. Oh, this is for the, okay, so for the training, we're going to like generate some sort of neutral image for some reason. See, I don't understand why we don't just start with like the start of the training video. That's the part I'm missing. Why get this to VA encode? Maybe it's sort of meant to be like an average image. But we get all the poses, we get the actual video, and we add the noise, and then we're sending that through to like reconstruct the actual frames of the original video. And there's just this communication where the animation module, which is learnable, makes me think it's probably like a LoRa because it's just feeding. Well, it depends on like this backbone DIT is frozen, so I'm very curious what this green line represents. What is the interaction exactly? But it seems to be all the blocks of the human animation module contribute to some of the blocks of the backbone DIT. So we have a larger backbone DIT, a smaller human animation module, where like there's literally less layers because some of these layers don't have anything incoming, right? We also have a garment transfer module where we are going to get from the source video, just generate the garment image. If the garment image exists, what? Synthesized? If the garment image does not exist from captured, what? Is this backwards? I would think if it exists, you take it from the capture. And then if it doesn't exist, then you synthesize it. That seems backwards to me. But maybe I'm missing something. But anyway, the DIT is doing all the actual generation. It's simply getting inputs. Interestingly, it also looks like the same blocks that take the like the pose input, which this is animation module basically just gives pose information to the DIT. Also, those same blocks are getting the garment information. And what is this pink line? So this pink line gives text information to every block of the backbone DIT and every block of the animation module and every block of the garment transfer module. That makes sense. That's whatever the prompt is. I'm not sure why we need a prompt here for try on. I'm actually kind of curious, like what that would be for. Is it the same prompt every time? Make this person look like they're wearing this image, this clothing? Do they clarify that? Let's try to find that real quick. Um, oh, we just get to we can do a twirl, I guess probably, right? I assume we wouldn't want to have like too many prompts we're trying to align to, right? Describing human actions and background context. Okay, yeah, that makes sense. It just gives more control. I guess that's fine. Sorry, did we look clearly at what's going on? I guess they're just showing us what's in the human image generation, right? Uh, I don't really want to get too into the details on this. It seems kind of interesting. I think the only thing I want to know before we go to the next thing, and before I answer some viewer questions, is just these animation and transfer modules. What are they? And like, what's this backbone? I'm kind of curious about like those implementation details. So let's first see what the backbone is. What is this pre-trained video? That should be hopefully in experiments, maybe in like, no? Okay. Architecture maybe? Maybe? Backbone T to V. Like maybe if we search T to V, we'll find it. Or I'm just gonna take some guesses. Tons of people are using WAN, right? It's not WAN. Huanyuan maybe? No? Um, if I search backbone, are they gonna tell me? What is this backbone? Do we know? Any other guesses? I mean, there's no way it's like an actual like just image DAT. We're not like learning video here, because that'd be crazy, right? Okay, I give up on that part. We will try to see that the architecture of their um human animation module, right? Human animation module, garment transfer module, ham, I like ham, ham and GTM, it's just a funny name, share part of the block architecture with, that's cool. Okay, so they just copy DIT blocks. The overall formulation is defined as, where B denotes each transformer block in the DIT backbone, L is the index of the transformer block, and K is a non-negative integer ranging from, oh wait, are they saying, hold on. Like, are they saying that when I see those green and pink arrows, I'm literally just adding the block outputs? That's what it looks like, right? It looks like, I imagine we were doing some interaction like the add a learner warmer and some cross attention, but it looks like we're just taking the outputs and adding them. Is that a good reading of this, do you think? You're new, Hutej, what's the stream about? The stream's about whatever you want it to be about. I mean, I'm going to read papers, and as I come up for air in between reading the papers, I will answer any questions that anybody has. I really want you to suggest papers for me to look at. Just because it's nicer than me just reading random popular things, right? Sometimes they'll all go off on these like 30-minute tangents that nobody cares about, and then the viewers will drop to 0. But that's okay, because this is, if it's what I want to do, I guess. I don't know. Anyway, feel free to ask any questions, though, and welcome to the stream. Nice to have you here. To provide tokenized... Okay, I'm reading this right. Am I not? Like, we're taking output of block with index, and we're just adding them, and we're weighting them with this alpha and this beta. And it looks like they say they just fixed those scalars at 0.5 and 0.5. I'm not seeing... So it's not LoRa. It looks like we're just going to copy the backbone DIT. I don't know how many blocks we're going to have. It's just going to be less. I think that's a minor implementation detail. You know, maybe they almost make it look like it's half as many blocks as there are in the backbone. And I'd assume all other dimensions are the same. They kind of have to be if we're literally summing tokens. That those, like the hidden dimension has to help. And so then the only other thing we're like haggling over is, oh, is the number of heads different? Which it's probably the same. So I think we've seen enough of this one. You're going to request we do Siren? Sure, we can do Siren. Sinusoidal representation here. Can I actually get it? I don't think this ever works. Oh. It does work. Maybe because I've searched it before. I swear I've tried it before and it doesn't work. Here, let me resize it if it needs to be. Can it be bigger? Did this format used to be different? Whatever. We're gonna... maybe 105? Yeah, there we go. That's awesome. Okay, we'll do that in a minute. We'll get through some of these other ones first. Thank you for requesting papers, though. It gives me something, like, very clear to do. Anyway, let's answer a couple questions, because I spent a while on that paper. I answered, what do you think of the future of meta learning? I answered what I do for my job, and that it's not related to video compression, it's video generation, world model. Hassan wants to know, what were you doing at TikTok? Did I put my new resume on my website yet? Let's see if I ever did that. If I didn't do that, I should do that. Let's see what my resume says. Does my resume have TikTok? Yeah, it does. Here, this worked on image representation learning for classification and generation, discrete representations for multimodal understanding and generation, and compositional image generation, papers under review. So I will show you. I'm not going to deep dive them because I kind of don't like talking about, I don't know. It's a thing about insecurity about my own work, I suppose. But this was from TikTok. This was from TikTok. This was from TikTok. There's another under review thing from TikTok, but I still think they haven't put it on arXiv yet. I'm not going over these. I'm literally just showing them so I can say what it was about. So as soon as they load, one of these has a ton of images, so it's going to take a second. Maybe one of these is loaded. Okay, so this paper, what was I doing? That hyper network thing with INR, except I first found that if you just try to train the INR hyper network, it can classify better than random. Here, that's right here. Classification better than random. But that's bad. 11% ImageNet, terrible, right? Better than random, terrible. If you do distillation, like from a good model, you can actually get pretty decent results. Not just on like the regular token, but the way that I designed this, it is actually kind of doing compression. We have this compressed tiny encoding. The compression is nice for saying we can compress the image. but I did not pitch this really as a compression paper for the reconstruction purpose, but rather compression for the understanding purpose, where you can get like 64% classification accuracy on an ImageNet with an 8D token. Like you can have an 8dim vector that gets 64% on ImageNet. I think the one I resubmitted to ECCV, I pushed that a little higher, but I don't remember. With the 32 dim token in this paper, we were getting 79.4. I want to say I pushed that up a little bit too, doing more experiments. But anyway, INR for everything. INR for reconstruction, INR for understanding. I took the latents, I trained a diffusion model on them. It was not great, but you know, it can generate images. I think those are in the appendix probably. Where are those? Yeah, I mean, images, sort of. If you see them, they're not super good. But yeah, trying to do the whole unified understanding and generation thing is hard. This was a paper from an intern. Jucheng was his mentor. Robert was our manager, Sohail is his advisor. And then, so Jucheng is very, very, very good with like RL and tool use especially. And I had more generation background. So I was helping a bit on the generation side, and Jucheng was helping a lot on the RL side, right? The idea of this paper was like existing models like Flux would really struggle to follow the instructions in the text, especially when it gets more complex. And so the idea was basically like you can have, if you have enough examples of like all the little ways you can violate a prompt, you can use RL to train a model to not ignore all the little things in the prompt. And you basically get those images that are so specifically different from each other by taking a model that struggles to listen, getting its initial image, and then just QAing it over and over. VQA. Does this follow this aspect of the prompt? No? Okay, edit it. And just keep repeating that until you either get the image or you reach some steps and you give up. So I guess the first idea is you can do this test time scaling to eventually follow the prompt. And the other idea is when you take those things, you can do RL on the original model to actually follow it, right? And so you'll see, like, we can actually get the panda in the green hoodie, the parrot with the blue headphones, both of them are riding skateboards, the city street's busy, and the sun is setting, right? Said I went deep dive these. I'm not, but I'm just explaining what the work was. And then this paper was some video stream understanding. And specifically with this, like, the main thing is there's this problem in models like Qwen 2.5 at least, or Qianwen, where if there's a really, really long video, no matter what your question is, if you look at the similarity in the KV cache, it'll just look like the later frames are more similar to your question, which means if your question has to deal with something earlier in the video, the model's just not going to want to retrieve that. So we try to break that, right? So we propose a way to change the attention post-hoc training free, and then we also find that you can take more recent vision encoders, like let's say your Qianwen 2.5 uses its own vision encoder from whenever it came out. Well, you can take things like PE core, and you can add them in. We need to rename this, but at the time we called it MOE. Kind of misleading, but better names we could have come up with. But when you add in like the PE core, you can get, this is a great example, right? So when you take like just the Qianwen 2.5 natively with our attention method, we could get like +5 compared to RecV. When you then add in that like other encoder, you can push the performance even more. So what was I working on? Image understanding, video understanding, video or image generation, I guess. Kind of a little bit of everything, right? No 3D. But the purpose of our team was to publish papers, at least the team I joined, right? Then there were some changes. The purpose of the specific team I was on started to shift more towards product, and so I left. That's my TikTok time in a nutshell. Okay, so can you recommend some research areas and generative models for undergrad? For undergrad, you need to find a mentor at your institution. And a lot of the ideas should be coming from whoever that mentor is, whether it's a professor, whether it's a PhD student. It's going to be very, 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 very hard for you to have on your own like a really nice idea, right? I can talk more about ideas in a minute. I should go over a couple of these papers. Oh, thanks for the kind words, Hassan. I don't know if I feel like I like what I was trying to do with some of them, or like only one of those was properly mine, right? I like what I was trying to do with my main one. It didn't work really, is the way I'd put it. And figuring out that we had the tiny embeddings that could do the good classification segmentation was sort of like, thank goodness this kind of worked, but obviously not what I was originally trying to do. I was trying to get really the proper unified representation. that wouldn't rely so heavily on the distillation from stuff like Dino. But it just didn't work. Anyway, let's take a deep breath and talk about this new benchmark. Okay. I can't remember, by the way, why I don't like MME, but maybe this fixes what I don't like, and maybe I'll remember as I read it. But anyway, Video MME V2, and it is from the Video MME team. Great. So they systematically evaluate model capabilities with a progressive tri-level hierarchy. Because they observed that the existing metrics are kind of saturated, right? They're designed to test things that old models couldn't do, but the new models can. So we have to adapt to that and propose a harder benchmark. Group-based nonlinear evaluation strategy that enforces both consistency across related queries and now multi-step reasoning. It's going to penalize fragmented or guest-based correctness and assign credit only to answers. Okay, so they're especially going to test the reasoning for the answers. 5 rounds of quality assurance, 3,300 human hours to construct it. And it reviews a substantial gap between the best model that they tested, Gemini 3 Pro, and human experts. So hopefully it takes longer to saturate this one. I'd say the fact that they can have that big gap suggests that it does work. So I think we answered our questions in the minute, right? We have the research problem, which is the old benchmarks are too easy. And the solution is make a harder benchmark by testing especially whether the reasoning of the model points towards it getting the answer for the right reasons, and also designing answers that require more steps of thinking. Remember, when we say things like they did use the word I think they used, right? Let's make sure before I just say it. Did they say multi-hop or did they just say multi-step? Let's see. Multi-point visual information aggregation, temporal dynamics modeling, complex reasoning. Maybe it doesn't say multi-hop like I thought it did. Maybe I hallucinated that because I wanted to just say that. Oh no, it requires multi-hop inference. Yeah, remember what multi-hop is, right? Multi-hop would be like me asking how many minutes per game did the player with the most points of all time play in the season where he scored the most points, right? You have to like answer who the players that averaged the most points of all time. Then you need to find like the season where he like averaged the most points, and then you can finally look up like how many minutes he averaged in that season. There's 3 distinct steps. You can't like skip to the last one. You have to answer the previous 2 correctly in order to get to the last one. So it's a hard type of question even for humans, right? Because any mistake that you make makes it to where you're going to get the answer wrong unless you just get struck by lightning super lucky, right? Anyway, I think we got enough on the benchmark. So the minute's fine. Let's do this paper real quick. Except maybe let's see if we have questions. Please, if you can, drop some research ideas if you're comfortable to. Yeah, I'm always comfortable to talk about, vague research directions. Maybe not the ones I'm principally working on, but just like other stuff that's kind of in my head. I'll talk about that in a second, though. Let's get this paper through. We did this one. We did this one. Let's get this Adam's law. And then let's talk about research ideas a little bit, maybe. Okay, this was the top upvoted paper of the week on Hugging Face, and it's got a crazy name. So let's see if it justifies it. Textual frequency law on large language models. So textual frequency is relevant to human cognition and reading speed. So they propose a novel research direction in terms of textual data frequency, which is an understudied topic. First, they propose a textual frequency law, which indicates that frequent textual data should be preferred for LLMs for both prompting and fine-tuning. Since many LLMs are closed source in their training data, we propose using online resources to estimate the sentence level frequency, then utilize an input paraphraser to paraphrase the input into a more frequent textual expression. Next, textual frequency distillation. It queries LLMs to conduct story completion by further extending the sequences in the datasets, and then adjusting the initial estimation. Finally, curriculum textual frequency training that fine-tunes LLMs in increasing order of sentence level frequency. Experiments are conducted on our curated dataset textual frequency paired dataset on math reasoning, machine translation, common sense, and agentic tool calling. I'm missing a lot because I don't know what this first idea is. Textual frequency validated as relevant to human cognition. I need to find where they give that background in the paper, and then the rest of it hopefully makes sense to me. So let's look for where they explain that. Larger models predict rare words better. Okay, so the abstract almost made me think a weird thing, which is like, we want to predict frequent words really frequently, but that seems like it would contribute to lexical impoverishment. So it seems like they were actually saying the thing that makes a lot more sense, which is we do need to try to predict things that are like in the tail in terms of sentence and word frequency. But let's see if that's really what they mean. Predicting rare words could be harder than predicting frequent words. Well, yeah, I mean, the model should naturally, especially based on the temperature and based on the sample, it should always be squishing towards, sorry, not should, but it naturally would squish and go towards like frequent patterns. It's kind of interesting though that the large models would go more towards the rare, because that almost suggests that they're like fitting the pattern less, but learning to like express within like the actual domain more, which is cool that they can do that. The use of paraphrases. Okay, this motivates to investigate when the data are paraphrased to each other with the same meaning but different language expressions. This was actually a major thrust between one of my first works and my only work in natural language processing, which was about machine translationese. I think I've talked about on the stream before, but the tendency of machine translation models at the time to translate in such a way that we typically pick the most common word out of, a bunch of possible synonyms. We always go towards one of them. Maybe if I could say, like in Spanish, if I say someone like is like correr, I would always translate it as like run. And very rarely would I translate it as sprint or dash or dart or bolt. Those words just would vanish. It's especially a problem when you're translating to a language like English that has twice as many words as a lot of languages do, just as a result of being, being German and Latin kind of smashed together. As a DA method, paraphrases are useful for training LLMs. Include all paraphrases, however, training resources. Okay, so they're saying like we know that we can reword things to get a broader diversity of expression, but obviously you don't necessarily want to do all of them, so what are the ones you pick? So when the meanings are kept the same, data with higher sentence level frequency should be preferred to the ones with low frequency. Okay, wait, this is actually suggesting the thing again that I thought doesn't make sense. Data with higher sentence level frequency should be preferred. Higher frequency data occurs more frequently than lower frequency data, so they're easier to understand. Sure, I mean that's the thing that's easier for the LLM. Calculate the frequency estimation through online open source data corpora. Sure. Further enhance the estimation. TFD conducts story completion of the text data set on target LLMs. The completed story generation is used to enhance the original frequency estimation. Fine-tunes LLMs in increasing order of sentence level frequency of the training data, which yields better results. So are they actually doing the weird thing I thought they're doing in the first place, which is train the data on the most frequent things more? I feel like I thought I was starting to understand. What? Why would we want to make the task easier? Here, maybe the chat's helping me. No? First time here, how's you doing? I'm doing good. Sahil? Sahil Ahmed? Ahmed Sahil? I assume Sahil's last name, Ahmed's first name maybe, so Ahmed? Is LLM pre-training almost dead? No, I don't think so. I think if anything, people keep trying to figure out how to like roll things back into the pre-train. But I don't know. I am kind of out of touch with whatever the frontier LLM labs will be doing. And I don't want to speak too much to what my own coworkers are doing, because that's kind of secret until it's done. But I just feel like in general, I know that in image and video, at least, it feels like there's this trend to like, how can we take our 10 stages and make them just kind of one proper stage? Pre-train, mid-train, post-train is just a very unsatisfying paradigm on a lot of levels. Anyway, I really want to understand this because it's really related to research I used to do. Translation prompt, high frequency rephrase content, better results. Sure. I mean, it's always going to do a little better with the data it has more of, but that doesn't mean you're making the model better when you just choose to feed that in. That's the weird part to me. Is that really what this is saying? Which is like, and why are we saying relevant to human cognition and reading speed? I guess it's just saying humans can read common things really easily. It's going to say neural activation between differences between low frequency words and high frequency words. High frequency words generally evoke stronger neural responses. So high frequency word, yeah, mentioned the impact. Then textual frequency plays an important role in artificial intelligence. So this indicates the impact of word frequency and semantic relationship retrieval. Larger models predict rare words better. So predicting rare words could be harder. So paraphrasing is important, evaluating, blah, blah, blah. I really think that they're just saying, figure out what the most frequent words are, right? Okay, let's go back to the abstract again. So step 1, figure out what the most frequent words are, using online resources to estimate. Then use an input paraphraser to paraphrase the input into more frequent textual expression. Then do textual frequencies distillation by querying LLMs to conduct story completion by further extending the sentences in the datasets containing the frequent things. and then use kind of the outputs of the LLMs to sort of guess even more at what the frequent things are, because whatever they're trained on is going to be more frequent. And then curriculum textual frequency training fine-tunes the LLMs using more and more frequent sentences, I guess, right? Are they going to have a figure where they illustrate that, how we sort of turn the dial from less frequent to more frequent? This seems weird. We're just going to squish the language and like make it even more biased to say things that are just like really, really, really frequent. But I guess we'll increase the solve rate on our hard tasks when we do this, because it's just easier for the model to understand. And as you teach it with things that are easy to understand, it understands the task better. I guess part of what you're getting at here is we want the models to solve a lot of tasks that just involve like semantic understanding and information, and using pretty speech is kind of separate from that. And so if we remove the demand on the model to use pretty speech, it learns to do the actual things better. That's my understanding. And I think I'm willing to stop. We're just looking at results that kind of validate that this works at this point, right? We're not getting like, I was hoping for some pretty diagram to kind of illustrate the dynamics of the curriculum. I'm not getting that. I think I'm ready to answer Chatter's questions a bit better. Or maybe we read Siren and then answer Chatter's questions better. Okay, let's see. Oh no, I got a few questions. Let's answer some of these. Okay. So first off, I have a couple people asking research areas in generative models for undergrads. Okay. So I can recommend areas, especially say undergrads, which implies university resources. So I recommend speedups. Speedups are pretty hot. And speedups are going to let you continue to interact with the hottest things, because you can't train a video gen model. You probably can't even do LoRa on a video gen model. Not a good one. But you can cache it. You can quantize it. And heck, if you do have a little bit of resource, you can do LoRa on it. You can distill it. And you can focus on speeding up, because the nice thing about speeding it up is if you are making the model faster, all of your experiments finish that much faster and you get the findings faster. So I really recommend, and this is what a lot of academic labs do, is focusing on speeding up the cutting edge. But please, whatever you do, there is just no reason to have the main result in your paper be SD 2.1. There are newer things that are open weights. And even if you could convince a reviewer to accept your paper on 3 years old model, like, think about your own brand. Think about who's going to be starring your GitHub. Think about who's going to be like signal boosting your Twitter. Do you want to say I made Flux 2 Dev 5 times faster? Or do you want to say I made SD 2.1 5 times faster? Make Flux 2 Dev 5 times faster. Don't worry about SD 2.1. Sure, you could get the paper in. Sure, you could validate the idea. It's just so much better for you to like not shoot yourself in the foot in this way. So speedups are great for when you're talking about generative models. You can also just focus on like fundamental things in architecture, like what my friends just did, right? But the flavor of your results is going to be different, right? They don't even have like ImageNet 256 properly in this paper, right? Their main results are going to be on smaller sets, like Celeb A 64, 128. They did do 256, but only Celeb A, and for fixed iterations, right? So you can do more fundamental things, but they're simply going to have to be smaller scale, and you're going to need to make sure that you have nice novel contribution. But those are two ways you can work. Where you aren't going to work is at like the actual bleeding edge of like the top numbers on artificial analysis, right? But you can go back and try to look for like issues with how we formulated the problem. You can try to study the architecture in like a toyish way. I would be nervous to study the architecture in a toyish way, because you're going to have reviewers that are just not convinced that your results would actually scale and help big models. So that's why doing something like the speedups could be safer. You can also try to do analysis things, right? Like people will publish like safety results on diffusion models. How much do these models generate content that's like not good? Meaning like nudity, for example. You could see how much the models are like copying or stealing, trademarked and copyrighted things. How easy is it to pull information that shouldn't be in these models out of these models? Those can be good topics for university work. What else in generative models? You can work on solvers. You can work on solvers that can be agnostic of the training paradigm. You can propose adjustments like, what is the name of this paper? Something your steps. Something your steps. Oh man, I should remember this. It was an NVIDIA paper. NVIDIA diffusion steps time schedule. Align your steps. For every diffusion model, can we solve the optimal schedule where maybe we don't want to actually take naively the evenly spaced steps, or we don't really get close to the actual ground truth, right? Whereas if we pick like better steps to use, we get a lot closer to the ground truth and we get better results on the existing model, right? These are things you could potentially work on. That being said, I'm not really answering the undergrad part, right? There's nothing really like, I guess if you're trying to like scope something specifically for the fact you're undergrad, I don't know. I'd say you can still dream big, and you'll just know that you need support, right? You need a strong PhD mentor. You need a nice advisor that supports that mentor. I don't think I would recommend that you necessarily pick boring problems. If you're just trying to learn, though, then maybe within one of these areas, pick a famous paper and don't look at the code and just see if you can match it. That's a great thing that you can do to try to make sure that you're learning. Okay, sorry. Let's get back to questions. More questions. I'll try to be faster. I answered the question of LLM pre-training. What do you think about this? PS in diffusion models. Oh, please, if you can drop some research ideas if you're comfortable to. What do you think about this in diffusion models? I'm interested in disentangling harmful social correlations. Text-to-image systems often entangle protected attributes with other traits from data. This affects fairness. Yeah, Bhavya, that's a pretty common Bhavya. Bhavya. I think that's better. Hopefully, this is a great direction for the university research, especially if you can show that you can change the interactions meaningfully with like LoRa or with lightweight distillation or with a limited fine tune if you have that many resources, or maybe you could even fix this by rewriting the prompt. You could do some RL with the learn rewriting the prompt, or maybe there's even a simple prompt you could use that would, remove some of these things. So I guess proving the extent to which they exist on different models could be helpful. You could even like propose a benchmark to measure the exact amounts of harmfulness of these different things. There's a lot of trust and safety stuff out there. I'm not familiar with all of it. People have definitely done flavors of all of these things that I'm saying, but it's a great direction, especially if you can stand up something that like industry people would actually be interested in using, because it could give them good signal to make sure that they avoid really bad PR when they release their models. So that could be a great research problem. Hi, Matt. Love your content. Thanks, Mitchell. What's your opinion on research topics of model compression, efficient computing for PhD? I think model compression is a great topic. It's a very interesting topic where there's way more approaches now than there were before, right? I feel like before you'd see a lot of like pruning. And always there's been neural architecture search, right? But you'd see a lot of like pruning of the pre-trained model. Obviously, that's what the original knowledge distillation was sort of meant to do. Large teacher, small student. And you see a lot of this model compression idea even in existing state-of-the-arts, right? Like the Dyna v3 that came out a few months ago. They train this, where can I see like the stats? Yeah, they're going to train this VIT7B 6.7 billion parameter model. But if we go to the Hugging Face, right, and we look at what do people actually download? Can we find the models? Dyna v3. How the heck did that pull up Tongi? I looked up Dyna v3. That's crazy. Yeah, if we look up, okay, let's go to Facebook. Let's find their, I hope Yoop is getting some love. I like it. Dyna v3. Okay, here we go. We can just compare downloads, right? If we look at the 7B, it's got 15,000 downloads in the last month. If you look at the VITS, it's got 335,000 downloads. I believe it's last month, right? Yeah, downloads last month. See, that's like an order of magnitude difference. And how did they get the VITS? Well, let's go look back in the paper real quick. So Dino has this self-distillation, right? But what this paper specifically does is trains a 7B model almost for the sake of just, can I see them say it more clearly? Like where they just say, we perform knowledge distillation of the VIT7B model into smaller vision transformer variants, S, B, and L, which are highly valued by the community. So you can almost look at this paper where they trained a 7B, but no one's going to use the 7B. It's not worth it, right? If we look at the numbers even, let's see if I can get the numbers in the same table. The returns are very diminishing. In fact, I think they never present them super clearly in the same table, because then it becomes very obvious that you wouldn't want to use the 7B ever. I'd have to spend a lot of time looking at the papers, but you can do it yourself. Compare the VIT-H that they have to the VIT-7B, and you'll see what I mean. So there's no point in using it, but it lets you train the powerful VITS, right? So this model compression is still very important. The community overwhelmingly, you're going to have an order of magnitude more response to smaller and smaller models compared to larger and larger models. Actually, let's look at this on the UPay collection, because UPay goes even smaller, I believe, with some of what they release. And so let's see if we can see this. So I know it's not as popular as their other works, but we're going to have B is bigger than S is bigger than T. Oh, they're not publicizing downloads. Dang. Okay. That's fine. Maybe it's, oh, is it because I'm not logged in? No, because I can see downloads for other stuff. I don't know. People are going to prefer your smaller models. Heck, we can go to my model. Or, okay, I don't think anyone's downloading my model these days, but we can see. I don't think they're downloading it anymore. Oh, they are a little bit. Okay, let's see. So I released an L, 6 downloads, and then the corresponding B, 14 downloads. And that's roughly what I was seeing before. My Bs were getting like, in the first month, they each got like 50 or so downloads, and the L got less. The community is always going to prefer smaller models. So model compression, great topic. Evergreen. Controllability and quality under counter-stereotypical prompts. Recent works made good progress in auditing and post-hoc debiasing, but open questions remain around causal control and quality. Preservation. I want to work on methods that keep structural semantics intact while reducing spurious demographic correlations. Yeah, Bahavia, I think that's a great topic. I think that early RL methods, especially that would have looked to reduce these kinds of things, would have resulted in a lot of mode collapse. And so if you can take some of the recent advances, the GRPO, and with like careful design of the LoRa, or maybe you're doing a limited fine tune, and basically have better data and better reward, you can hopefully keep a model that still follows the prompt in a good way while, not exhibiting these harmful properties. And potentially this even looks like just getting a model that's very good at the text following and then intelligently rewriting the prompt to anticipate these biases. And maybe the prompt rewrite even needs to be a little specific to the model because it needs to know those models' biases in order to counteract them in the text space. And maybe there's some interaction between these. How do you name a paper? That's a good question, Hassan. There are a lot of opinions about that. Some people, for example, like naming their papers with questions. Other people literally think you're like a big, stupid, ugly idiot if you use a question in your paper title. I think I have one paper with the question title. Let's see. No question, no question, no question, no question. Bam, question. I think that's my only question, though. Let's just look for question marks. Yeah, I just have one question. Some people hate that. I really don't like colons. Not a fan of colon titles personally. A lot of people love them though. A lot of people especially love to do colon titles with like the name of their method, right? Because it's like a branding thing. Personally, like to my own taste, that just feels a little bit too Twittery for me. It's like, okay, on Twitter, I can, put the name of my method big, bold, but it's like, I feel like the paper should be a lot more about like the ideas. And so like a lot of people with like my most recent thing were like, oh, you should put like Hoover at the front of it, right? But I'm like, no, I want to put like the thing that like is properly the contribution as like the only thing of focus. So personally, I like titles that are kind of punchy and just talk about like what we're really doing. I think well, okay. This has a hyphen, not a hyphen. This has a colon, which I don't love, but at least it's not the method name, right? Wutzel likes having like catchy little like phrases at the start of his. I think we can see that with his other ones too, probably if we click on him, right? Let's look at the ones where he is properly the first author. Going down memory lane. Oh, actually, is that the only one we really did it? Where's Mustafar? I guess that's like just a Star Wars thing. Okay, that's not fair of me to say then. That's like the only paper where he tried to do like the catchy thing. That's a thing people will do though. Try to put like a little catchy. Okay, so he's actually, the reason that you do like going down memory lane is it's trying to balance like catchy with actually informative. You cannot name a paper just going down memory lane. It doesn't make sense. You have to kind of say what it does. But this is trying to mimic like an image is worth 16 by 16 words. So you put the catchy thing first. It doesn't tell you much. It kind of indicates like, oh, could this be some patching? And then it tells you what the paper's about, right? Transformers for image recognition. So this is a style. Catchy thing. So some style would be your method name and then something that tells me what the paper is. Another style would be just random catchy thing. Then tell me what the paper is. I personally prefer just tell me what the paper is. Sometimes you get the best of both worlds. I feel like this one is kind of catchy. How to design and train. I was going for the reference sort of to How to Train Your Dragon, or actually there's a paper I really like. I should remember the titles of all the papers I like, but it's like How to Train Your CNN. I'm trying to remember what the paper was called though. I can't remember what it was called. I was kind of trying to go for that flavor though. Anyway, those are some ideas I have about paper titles. Next question. Seems like the most fun part of writing a paper. Imagine the authors naming it Attention is All You Need. Yeah, that's a fun one. I feel like Attention is All You Need makes tons of sense though if you understand where the community was at the time, right? It's like basically we knew that we needed to solve the long range dependency issue somehow. And a lot of that was like, oh, can we just kind of carry it in the hidden state all the time? And like the recurrent update will always maintain this hidden state that will sort of keep the long context. Then another idea was like, okay, but like having to like just recurrently process everything can be really, really, really slow, especially if that's how our training passes work. And it doesn't handle the long context dependency. So we put in attention to try to capture some of those long range dependencies. At the same time, some people were trying convolution, and the idea is like, okay, with the convolution, you don't actually have to do all the passes of the conv filter in sequence. You can do them in parallel, right? So the conv could be like an efficient way to capture the neighboring word dependencies, but neighboring word isn't long range, so that's obviously not solved. Well, attention kind of one-shots both of these problems if you just strip out the RNN part, and suddenly you have a model that the attention is parallel, like the conv can be, and it doesn't just capture the short range dependency, it captures the long range dependency. So when you take the seek to seek that we put the attention in, and you just take out the recurrent part, all you're left with is attention, and it turns out attention is all you need, right? And that's what they're going for with. So it's almost like, I don't even know if they really tried to pick something that was going to be so catchy, or if they're just literally talking about the fact that when you compare it to the prior works, you know, that are going to be recurrent or convolutional or self-attention, it turns out all we need is the self-attention. And you can see that when we compare to like the conv stuff, right? We're going to get better translations when we just do the transformer, because you only need the attention. And the flops are going to be like order of magnitude lower, which is crazy. So attention is all you need, right? So sometimes I think those good paper titles will just kind of strike you like lightning based on the nature of the problem that you're solving. When you skim a new paper, what signals tell you it's actually worth reading deeply? By the way, my first name is Sahil. Okay, thanks, Sahil. Or Sahil. Hopefully you'll get a feel for what tells me the paper's worth reading as you see me open and close them. It's kind of hard to say, and I am a little more forgiving on stream than I would be on my own. Like, on my own for some of these, especially if a viewer's not suggesting them, I'm really not going to try that hard if the paper is making the information really, really hard to find. In Vision, a signal that the paper's good is going to be that they're following standard conventions. Like a Vision paper should be giving me, like a Vision, an applications paper especially should be giving me a good teaser right here. Obviously, Siren's not like a applications heavy paper. It's kind of more in between applications and theory. Still though, like this is a decent teaser. It's just not on page 2. So it would give me like a decent teaser, and they would probably give me a decent methods figure. This paper, unfortunately, it's fine to explain the method in math, but this paper is mostly going to explain the method in terms of the math, right? So it's not going to have a big figure. Typically, that means the paper is a little harder to read on stream. It doesn't mean that it's bad. I think it's nice, though, to give it a good diagram, especially because I think the math can only get you so far, and the math is really tightly entangled with the English, and a visual representation can sort of transcend the language barrier, where sometimes a lot of details can just get lost in English that not everybody understands or writes. English that not everybody writes equally well. And the figure can often resolve certain ambiguities that you'll find in the text. So I'm looking for good figures. I'm looking for, like, when I find a figure that I can quickly trace it to the thing in the text, I'm looking for text that, like, the structure makes sense. They're telling me how things work in order. Like, I can find close to the top of the paper what the problem is, what they're trying to do to solve it, and why. When I go into the experiments or the methods, I can find what the method is, how it's actually implemented and instantiated. Like, things that'll make me mad are when, like that Triumph paper where it's like I just can't for the life of me find what the backbone that they freeze actually is. Is that literally a pre-trained DITXL on Imagen? I don't think so, but what model was it? I couldn't find it anywhere. And that's a sign that there's so many papers out there and so many are written so well. You just only need to waste your time on a paper that's written poorly if it's like really, 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 really important to your research. Otherwise, your time is better spent just reading a better paper. Yeah, a mentor is very much needed. I'm targeting a PhD position, mid to low rank. My recent paper is accepted to a WACV workshop and also working on another paper. That's great, Ifta. Congratulations on the WACV workshop. The nice thing about workshops, even if they're at a second tier venue, is you still get eyes on it from all the other people at the workshop. Sometimes workshop papers that are in an application people care about get cited even more than like your top conference papers. One of my most cited first author papers is a work on racial bias in faces, in like face classification, which was accepted to an ICCV workshop. And that has more citations than maybe any of my first author top conference stuff. It, yeah, well, because my most cited first author thing is a co-first author, and it's the preprint, not the conference accepted version. What do you suggest, Matt? Is it wise to target? It is very hard to come up with a good idea without a mentor. True, Ifta. What do you suggest? Is it wise to target PhD programs at a mid to low rank school right now, or should I publish in a top tier conference before reaching out to professors? Ifta, I would say it totally depends on the opportunities that are in front of you. I don't know what country you're in. I don't know what countries you could get right to work in. Um, it's hard. Like, would it be better for you to do a PhD at a mid to low rank school, or do you personally maybe have better opportunities going to industry? It's really hard for me to say that without knowing what you consider mid to low rank, and also without knowing like what jobs you could actually get in the industry if you chose to do that. Should I publish? But that's the thing you should be evaluating, by the way. Like, do I have better opportunities to do what I like if I take the PhD that maybe is a little less prestigious, or if I choose to take whatever I can get in the industry? Because going to industry, you can potentially kind of climb your way closer and closer to some of these problems. Or maybe someone sees that WACV paper and that's exactly what they're looking for, and you can do something research related to that, even just with the experience you have now. So it really just depends. Should I publish in a top tier conference before reaching out to professors? I think you can reach out to professors now and just see what they say, and that might give you a good signal. They'll either ignore you, which tells you one thing, or they'll say something not ignoring you that tells you another thing. Funding's a little tighter than it was, so this may be trickier, but you could also ask for internship from those professors, right? It's not as big of a commitment for them as actually admitting you properly to the program, but it gives you a chance to show that you can do good research for them. And if your WACV paper is heavily aligned with what they do and they have some money, there's a good chance they might be willing to, see what you can do. That could even be a good way to see if there's a good fit at a mid rank for you. Maybe you're skeptical of the mid rank, but there's actually a PI there that would be perfect as your mentor. And the internship could be a way for you to kind of like try things out, right? I know lots of people that do that. It's like a 1 year research assistant position or like research internship. Maybe not as common now as it was, like I said, when the money was more free flowing. But anyway, similar question to one above. Hi, Demir Shodiev. Is it the end if I don't have a star in RLDL before applying to top PhD? Is it the end? Um, it depends. If you have letters from famous people, it's not the end. Strong letters from famous people. If you're trying to get into top PhD without top paper and without top letter from top professor, then yes, it's the end. That may not have always been true, but it's especially true now with the field being so competitive and with the spots being so limited due to funding factors. Um, yeah, there's nothing wrong with a mid-rank PhD though. I mean, there can't. So you're going to need to be aware of what you're walking into, and you're going to need to work hard, and you're going to. But yeah, totally. Lots of people do great PhDs at low-rank and mid-rank schools. There's nothing wrong with that, and you just kind of need to evaluate what your opportunities are, and maybe you do have better opportunities in industry, or maybe the PhD at the mid-rank is your best opportunity. And if that's fully funded, it's an opportunity for you to take a risk on yourself and just try to do high leverage research for 5 years. Hey, I'm back. Do you remember me after the last live stream? Coding by Sammy? Um, yeah, vaguely. Um, I think I do. Yeah, I think I do. Thanks, Matt, for sharing your opinions on model compression. Maybe you've already answered my videos before. What's an ideal day for you during your PhD? Thanks. What do you mean, what's an ideal day? Like, what do I accomplish in an ideal day back during my PhD? Um, I think an ideal day for the PhD for me would look like spending some chunk of time uninterrupted making, like, basically, so I'd start the day, I would make a list of everything that I want to accomplish in the day, and I would try to spend at least a few hours working on those things. I would also ideally have, some conversations with other people in the lab about what they're doing or just like sharing ideas. And then On a good day, I scoped the list well, I finished the list, I go home. Sometimes I get to the end of the day, and especially if I've been talking to more people, there would be items left over, and I would just put them on a new list for tomorrow, and when I show up the next day, my list already has some items on it. Sometimes instead of a daily list, I'd have a weekly list, and I'd put the dates on each thing, and if I didn't get them done on that day, I just cross out the day and put the next day or whatever. But this tended to keep me honest and make sure that I had, a few good hours where I was moving towards what I needed to do. And it would help me make sure that I wasn't like forgetting to do certain things that would end up blocking me later. But yeah, that was a good day. Make the list, burn down the list, go home. Spend some time with the kids, cook dinner, stuff like that. Yeah, a good day, I would be getting there, 8 or 9, 10, leaving 4, 5, 6, somewhere in there, getting home, making dinner, um, putting the kids to bed. But yeah. Thanks, Matt, for sure. Okay, I answered that question. I would suggest don't get to PhD until you finished it with until you finished with it. The gold rush will be over. I don't know. Saying that the gold rush will be over is almost like saying it's a bubble, and I don't know if it's a bubble. I'm pretty skeptical at this point that it's a bubble. I tend to believe a lot of the money that's here is going to stick around or potentially even keep going up for even longer than the time frame of a PhD. But who knows? Depends on what we achieve in that time span. Can you give an example of a paper that is written extremely good? Yes, I can give an example of a paper that's written extremely good. Really, any chiming paper, but like this one. I'm gonna make a. Is this one of the papers I'm sending the video around? I don't think so. Maybe it should be because it's just like written so well and clearly. Let's see. Let me check my crop a little bit. Yeah, I need to crop this different. Let's see, 85 maybe for the vertical friends. So like immediately in the paper, they show you exactly what they're getting at. That the deeper network initially has higher training error and thus test error, right? So they're saying like we have a really hard time training deep networks that actually learn properly. So how can you make them deep? And then they tell you what they're going to do, which is propose a building block for this residual learning. And then they're going to give you the whole diagram in great detail, and you can see exactly what the network is compared to the previous VGG. And they'll give you even more details that you can see what the network configuration looks like at each different depth. And then finally, they're going to show you how you can actually get, with their method, a lower error rate on a deeper network, right? Without their method, 34 layer, worse error than the 18 layer. With their method, we get better learning. You're going to come down here and you're going to see all the results. They're going to report it in terms of error because that's how we tended to report things at the time. Now we report them in terms of accuracy more than error, but like this was the convention. And yeah, I think this is pretty solid. Obviously these plots might be a little bit foreign to people that are more used to reading like more recent papers, especially VLM papers where everything would just be in these big tables or like these big star plots or radio diagrams or whatever. But like this is what we did at the time, right? And so you'd even have it even follows a convention, you'll still see a bit where we have like some kind of like main results, right? And then we have like, oh, by the way, a couple more tasks, Pascal VOC and MS Coco. And then we have those right here, comparing their method to the most recent state of the art. So it's a nice self-contained paper. Does it do every evaluation possible under the sun? No, right? Like on the Coco and on the Pascal VOC, they only compare to the VGG, and they don't even compare like all their different network variants, right? It's just the ResNet at the 101 depth, which actually did not end up being the most popular depth, right? The most popular depth ended up being the ResNet 50. This guy right here. Nice balance of performance and depth. Where the performance I mean accuracy, and by depth I just mean like the more layers, it's longer to compute, right? Longer to train, longer to fine tune, longer to do inference. So the ResNet 50 was super popular for a very, very long time. And then they expand some results in the appendix just to continue to convince you that it's better. I really like this paper though. It very clearly explains what the problem is. The solution is super easy to understand, and they justify the key design decision very effectively. So I think it's a great example of a well-written paper. Not advising this, Sam says, but some people start a PhD at a mid-low rank university with the intention of mastering out and aiming higher. Yeah, starting as a PhD student and then intending to master out and going to a higher tier university is not something anybody at the university you're at would be happy with if they found out about it. It's definitely a lot more proper to actually go as a master's student, right? But then the difference is that you're paying and you don't have like the security where if it runs out that you are a PhD and you can still stay there. So that's tricky. Certainly the more conventional thing, if you could afford it, would be to go as a master student, make sure from day one to find a research lab to work in and try to get a good paper in that first year. So then when you're applying the next cycle, you have a letter from that good prof and you have a paper from their lab, right? Because if you could get a PhD at like a mid or low, you can probably maybe get a master's at 1 top if you applied to 10. And so that's kind of your opportunity to sort of, ladder up in terms of your resume, get that top paper, get that top letter, get 2 top letters. Who knows? You'll get to take some courses as well, do good group projects, go to office hours, participate in the course effectively. Pretty much any prof does take note of the people that are really actually contributing to the conversation. And it's not like an amazing letter, but it's a way better letter than the person that's just like, oh yeah, they got an A. Like if you had meaningful contribution in the class and they feel like you're like a good thinker, most profs will be willing to speak to that. Anyway, earlier I think Hassan asked me to do Siren. So let's talk about Siren. Let's think I'm not going to speed read it. Let's think about the best way to present this because it's going to be a lot of math. Do I want to just say what like the math means? Okay, I think, how do I want to present INR? So the whole idea with implicit neural representation is we are going to learn, like, is there a good visual in the paper for this? So this is the class of function, right? Where the input is the coordinates x, right? These are essentially coordinates or derivatives with respect to the coordinates, but basically just coordinates, right? The coordinates are some embedding of the coordinates, and then map x to some quantity of interest. So I've seen different reasons we say that it's implicit neural representation. The way that I like to say it is it's like an implicit representation because the signal itself is parameterized within the network. Like the function and the weights of the network give you the signal when given coordinates. It's like we have like explicit representation where we pass the image to an encoder, the encoder gives us some vector, and that vector is like an external representation. Whereas with the implicit representation, we just adjust our weights until like all the information is like inside the weights of the network. You can learn any signal this way as long as you can describe the signal with coordinates. It doesn't matter if it's audio, video, 3D, whatever. You can learn it in a neural network like this. Via sign distance functions or solving boundary value problems. The way this actually ends up being instantiated, and let's see if I can find math that supports this like in a super obvious way. Yeah, let's see if I can find good math. Yeah, is we're going to learn weights. An affine transform defined by a weight matrix and biases applied to the input, followed by the same nonlinearity applied to each component of the resulting vector. So yeah, we can stack layers of a network that is essentially, we stack linear layers, right? This is like some nice rectangular matrix. And it basically ends up being an MLP where we have a linear layer and then an activation. And on the input side, we can give the coordinates like x, y, but everything ends up working a little bit nicer if we first embed the coordinates x, y with some function. And basically, so there's one other paper that came out roughly at the same time as this paper, which is Fourier networks. And both of these papers are using MLPs to reconstruct images with coordinate input. The main difference between these papers is how they, this is a good figure. So this is showing you a coordinate-based MLP, right? So this is showing you can take RGB as input to this dense network, and then you can take X, Y as input to this network, and you can get RGB out. But what they're basically just saying is, we have this function, this embedding of the input, and if we don't do anything in this embedding, in other words, if this function just yields the same X, Y, our images are really blurry. It's hard to learn. But if we have, in their case, they suggest Fourier features, and you just do a projection of X, Y into this Fourier feature space, you can then get like really nice sharp images. That's essentially what this paper is doing as well. Just it doesn't use Fourier features, right? Let me see if I can find where they actually define the embedding properly. Like where do they show their embedding function really nicely? Their what they process with the input X. Because this is they focus a lot on the activation in this paper, but really the thing that starts to make INR work is having this positional embedding. And I'm trying to find if they even really talk about it properly in the paper itself. Like the activations are important, and a lot of like later works look at like even better activations that we can do. But really like the big thing is we have to do a positional encoding. Activations, frequencies. Let's see. If they don't talk about it, that's fine. I said we don't have to like read the paper, and that's okay. Okay, but the gist of it is just to keep in mind, remember, we can learn any signal that has coordinate inputs, right? So images have x, y. As long as we can define some coordinates for 3D, which we can, it can also learn 3D volumes. If we add a t, it could learn videos, although in this paper, I don't believe they do videos, right? What else? I think in this paper, it's really just images in 3D, right? And they show it doesn't really matter how you define the implicit function. It can just kind of work. Yeah, I think that's what I want to say for Siren for now. And that's fine. You also got to see Fourier FeatureNet a little bit as well, FFN. So that's Siren for you, Hassan. I hope that is roughly what you want. There's a lot of math in the paper, but it boils down to train an MLP that embeds XY in maybe like a 54 dimension embedding or something. That's at least the dimension I think with the FFN. And then just have all these linear layers with like a sinusoidal activation in between them. And those linear layers, the first one will project like your 54 dim input to 512, and they'll just be 512, 512, 512, 512, 512, 512, and then 512, 3. Those three are your pixels RGB. And so when you pass in all the coordinates, you get all the RGB tuples that you need in order to have the image. And I said earlier that supports inpainting because you can use fractional positions to paint non-existent points. And that's how NERF does novel view synthesis, because you can give like an array that wasn't actually in the train data, and your model will interpolate in this like very complicated space it's learned to solve. So you can do inpainting. You can also, for images, you can give a coordinate that lies outside the frame, right? Let's say your first coordinate 0, 0. You can give -0.1, -0.1, and you can get that pixel. So you can do outpainting. I'll actually show you how that looks in a different paper. From Mohammed Aloysani's lab. Yeah, here you go. So this is the generated region properly, and then you can interpolate outside, or extrapolate, sorry, you can extrapolate outside the boundaries by passing coordinates that are less than or greater than the min and the max within the image. That's what's going on here. So that's a key strength of INR, is that you can do this at all. This doesn't exist in other paradigms of image representation. Okay, so we did Adam's law. Let's answer some more questions, do some more papers. From this resonant paper, I remember the CV series you're about to start. Any updates? Yeah, Hassan, the big update is work has been crazy. I was up till like 3:30 a.m. on Thursday and up pretty late on other nights just working on like my day job. So I'm tired. I haven't even had time to like edit the stream to get shorts out or anything. I will do that series eventually. Things will calm down at work. But for now, it's like basically all the time that I have goes into work or family, or I did protect at least the stream time. So you get this. Eventually, the CV series will happen. That's happening. That's a series I really want to make. I just have not had the time these past few weeks. I'm sorry. It's coming though. I swear it's coming. Okay, let's see what we wanted, because I don't think I'm going to stay live for too much longer. So let's try to prioritize. I wanted to see this one, the trigonometric KV compression. So let's grab this guy. Let's see what else looks good. We can look at another baseline. That's fine. I kind of want to know this just because I hypothetically sort of work in that area, right? A diagnostic benchmarks for paraphrase robustness. I want to know what they were going for with this. Let's look at this one right now. Like, let's not even go to another paper. Let's just like, let's one shot this. Let's one tap it. Let's just get in, 1 minute, get in, get out. What do they mean by this? All right. A diagnostic benchmark and metrics for paraphrase robustness in VLA models. So they achieve strong performance by leveraging pre-trained vision language models, but in downstream robotics, they're typically fine-tuned with limited data, which means they really need this instruction to be worded properly. To study this gap, they introduce a benchmark that independently varies action expressions and object references for fine-grained analysis of linguistic generalization, and they observe consistent performance degradation under paraphrasing. So if you just change the words too much, even though they mean the same thing. It's driven primarily by object-level lexical variation, so synonyms can cause large drops. Many failures arise from planning-level trajectory divergences instead of execution, showing that the paraphrasing can mess with its ability to identify the actual task. So they propose a benchmark that quantifies the paraphrase difficulty under semantic and syntactic factors. Let's see how fancy this is. So, okay, this doesn't really define. We could zoom in more maybe. But it looks like they're basically saying a real model needs to be able to handle lots of different ways of saying the same task. That doesn't happen when the data is limited. We need to see just how bad the models are doing, basically. It looks like they're saying you can fine tune on their stuff eventually to be able to, like, it looks like they were going to say that you could fine tune, or no, is it never fine tuning? It's only ever analyzing the failures? I guess it's only ever analyzing the failures, right? But it's basically just saying the pre-trained model can turn on the stove, but it can't fire up the stove, initiate the hot plate, or answer it in this question for whatever reason, which I suppose is good to know. They're saying compared to the other benchmarks, they have full control over the paraphrase. They do it for actions and objects instead of just like messing with the sentence. So I guess they're saying it's more controlled. They intentionally manipulate the action. They intentionally manipulate the object. They have lots of types of paraphrase, but it looks like this is a known issue. So there are other benchmarks that look at the paraphrase sensitivity. I also think if we're zooming out a bit, this is the kind of work that can be like interesting for 2 minutes. But as soon as you have someone that can really afford to like train the VLA at scale, this problem mostly vanishes. So I don't know how interesting I find it as somebody that like doesn't work on the specific problem, because I see it as a problem that's like kind of like a blip. Like it exists for a small moment that you have a lot of labs that don't have the resources to tune the VLA, but it'll go away the minute someone releases a VLA that's able to like, or has like a pipeline where they're able to train for a lot more time on a lot more like lexical diversity. It also vanishes the minute someone just proposes like, hey, let's do a rewriter. Let's know what the distribution of our like lexical frequencies is in our fine-tuned data, and let's make sure to always squeeze and massage the input prompt so that it matches. And that kind of rephrase could be done by like a 0.6b LLM probably. So something that's like relatively cheap to do the forward pass, where you can do the forward pass in real time, which is what your VLA model probably needs. Anyway, I wanted to see this. So let's maybe take a look at this. And then were there any other papers that y'all really wanted to see? Let me know so I don't like miss them, because we aren't staying online too much longer. So this is a great time to get like your last request for the day in. I'll probably go offline by 11 p.m. Sorry, 11 p.m. Wow. By 11 a.m. Learning massively multitask world models for continuous control. Okay, sure. Wait, did I have that one open? No, it's 2025, so definitely not. Oh, it's from Xiaolong's lab. Cool. I hadn't seen it before though. Whoa, what did I just do? Sorry. Let's check my alignment real quick. Okay, I can zoom in on this one more. Let's see. No? Can I even go to 110? Yeah, buddy. Awesome. Perfect. Okay, let's take a look at this one. Let's try to do 1 minute. I should take a breath. Hold on. Also, let me make sure I'm caught up with the chat. I think I am. Let me know if I missed any of your questions. I didn't mean to. I don't think I did. I think I'm good. Learning massively multitask world models for continuous control. So control demands agents that act across many task embodiments, yet research on reinforcement learning for continuous control is dominated by single task or offline regimes, which makes it seem like online RL can't scale. So inspired by the foundation model recipe, which is large-scale pre-training followed by light RL, we try to see if a single agent could be trained on hundreds of tasks with online interaction. To accelerate research in this direction, they have a new benchmark with 200 tasks spanning many domains. We then present Newt, a language conditioned multitask world model that is first pre-trained on demonstrations to acquire task-aware representations and action priors, and then jointly optimized with online interaction across all tasks. Okay, so let's see. Average across tasks, they compare theirs to prior agents, I suppose, that could have done some of these things, and they succeed, maybe on over 40% of the time compared to others that struggle to get more than, like, even single task baseline, it looks like they're saying could be close to like 25%. So what's this, oh, hours no demos. And then FastTD3, I guess, is a competing method that's pretty solid. So I guess they're saying they're not the first. There's this task, there's FastTD3. Maybe we should try to see what that is. Maybe that's going to be, not in the related work, right? Because first we're talking about the benchmark that they introduce. So let's try to go down to the related work real quick. I want to understand if there are prior benchmarks that are kind of similar. I guess they're putting this at the end, right? Okay, so benchmarks for multitask RL, most have been designed for single task training and evaluation. That's true, for robotics at least. While some benchmarks evaluate policy learning and generalization within a narrow task or task family, multi-domain learning is mostly underexplored. Similarly, several works propose multi-embodiment datasets for imitation learning and robotics, but we've yet to see a comparably large initiative for multitask and multi-embodiment RL, let alone multi-domain RL. So they consist of 10 distinct task domains, each with a variety of tasks. So they're basically just saying their benchmark covers more task domains, bigger variety of tasks, bigger variety of embodiments with different reward functions, demonstrations, language instructions, and visual observations. So I guess they're just saying, it's the broadest benchmark that covers all these different axes. It's not one embodiment, it's multiple embodiments. It's not one type of demonstration, it's not one type of instruction. It's not even one family of tasks, it's many. And for scaling RL, let's try to find this FastTD3 and kind of work backwards from there, if we can. Are they going to mention it by name? I don't see it. A modern implementation of TD3 designed for RL with parallel environments. We extend FastTD3 to support language conditioning and per task discount factors and find that end-step returns of 8 are critical in our challenging multitasking. Oh, okay, so their FastTD3 is already kind of their reimplementation and extension of FastTD3, which is interesting. I don't know enough about that. They say it's more data efficient, though, than even their extension of the method, so that's good to know. We base our TD3 implementation off of FastTD3, an improved implementation of TD3 designed for the era of RL with large amounts of parallel environments, demonstrates robust learning across a number of different benchmarks, but has not previously been evaluated in multi-domain. So they extended to support language conditioning, then they evaluated in multi-domain. Okay. Cool. I still don't really know what it is. I think I would need to go to the TD3 paper to know what it is. I don't think I want to do that right now. That's obviously going to make it hard to understand this paper, right? If I'm not understanding some of the prior works, but that's not like quite the level of time I wanted to spend on this. So the key things here seem to be that we are, okay, so let's look at section 3. It looks like we are first off going to learn a model that can sort of, from this pre-training, then transfer via, I believe it's imitation learning is the transfer to all these different tasks, right? So it learns this world model with a combination of joint embedding prediction. So that kind of like the JIP idea, right? Self-predictive dynamics modeling, reward prediction, TD learning. This is in contrast to generative world models that are typically trained to decode raw future observations. Okay, so they're saying this is the type of world model, not in the GLP family, probably more in the JPA family, where we're predicting the embeddings, we're not trying to predict raw frames. The benefit of the self-predictive world model is, in addition to being computationally cheap because we don't have to predict RGB, it's control-centric because it's predicting an outcome conditioned on a sequence of actions. I'd argue that you're also predicting the action if you predict you're also predicting the outcome if you predict pixels, right? You're just predicting it in the pixel space, not in like the latent space. But anyway, their proposed world model extends the TD MPC2 architecture to support language instructions and optionally RGB observations. Let's look at their method. So their agent, Newt, iteratively collects data via multitask environment interaction and optimizes this world model on the collected data. The world model takes a state vector, which is like a clip embedding of the embodiment and the instruction, it looks like. It looks like this is clip, right? So we take clip on the language, which that's crazy to me that we're using clip, but okay. Dynav2 on the like frame, and somehow this state observation. I don't know where that comes from. Maybe I'll see. Maybe that state vector is something we update somehow. So, and the RGB observations are optional. Okay, I guess it maybe depends on the task. And then we can take some actions, and each of those actions are associated with a reward. And I suppose that's where we compute the loss, right? The Newt architecture, self-predictive world model. So we get an encoder, and then the encoder gets mapped to actions and what is the? Yeah, it's actions, it's returns, and it's like the local reward of the transition. Okay, so they're trying to predict the reward. So they're trying to predict the optimal action, the associated reward, and like the cumulative reward so far on the trajectory. And this is the joint embedding prediction idea. So we have the stop grad on all these other steps. Okay. So yeah, this is just JPA with action, reward, and sum of reward and terminal value. What is state observation though? Like a latent state representation, sure, but where did that come from, right? Because I have the X that comes from Dyno. X, I have G. What is H? I guess I just need to look for how we define H, right? And then I'll know. Let's see if we can find H, yeah? Where? Components that take multiple arguments as input fuse their inputs via concatenation before feeding them into the first dense layer. So we let H of S sub state xg equal H of sure. We just concatenate the states, right? But where does S sub state come from? Okay, maybe chat's trying to save me here. Nope, chat's not saving me. Help me, Sams. I assume you asked for it because you may have looked at it before. Where does state come from? Is this something that I'd be a little more familiar with if I knew more robotics or more RL or more JPA? Or is it a detail that is just a little underexplained here? Man. The policy prior P is formulated as a stochastic maximum entropy policy that learns to maximize Q values as estimated by a Q network defined above. Oh wait, what's the Q network? Hang on. We let Q target be an exponential moving average of the online Q network as the minimum value as the minimum of a random subset of Q target estimates. We choose to use per task discount factor since episode lengths vary drastically between tasks. Is the Q network even in this diagram? No, right? That's just sort of implied, I think, in what we're looking at here. What is their encoder? Like, what's the architecture of the encoder that's predicting their state? Like they get these out of the encoder, right? And this almost makes it look like it's like RGB in here. Oh, is that why this RGB Dyno V2 observation is optional? Because is this encoding acting on the pixel observation anyway? So it's like we can take the Dyno V2 features to like help, but we're always processing the frame. It's kind of what it makes it look like, but I'm not really sure. And this is talking a lot about the Q network estimation, but it's not really answering these details that I'm asking. Model-based BC, Q-value entropy. Yeah, this isn't answering any of my questions either. Model-based pre-training. Prior to any online interaction, we first pre-train all learnable components from equation 1 on the provided demonstrations. Specifically, we assume that demonstrations consist of SAR tuples, state, action, reward tuples, and jointly optimize all components by minimizing the loss, but with the Q-value term in equation 3 temporarily disabled so that we can fully leverage the strong action supervision from the demonstrations. Okay, so we turn the policy off and mainly prioritize matching the supervised demonstration. Constrained planning. While transitioning from the pre-training to online RL, we empirically observed that at the start of RL, planning with the world model yields a weaker behavior policy than directly using the pre-train policy due to a comparably inaccurate value function. How do we pre-train the policy again? Although one can easily add demonstrations to the replay buffer at the start of training and indeed benefit from the model-based BC term introduced in equation 3, we would like to utilize demonstrations to the full extent. Concretely, we propose to utilize demonstrations in 4 distinct ways. Okay, I'm a little confused by the explanation of transition. To retain performance when switching to plane, we inherently bias the planner towards the pre-trained policy and linearly anneal the bias to 0 during the first 12% of training. Okay, so we say that regardless of how we get it, the fact that the policy is better than the planner, or rather the world model has a weaker behavior policy than directly using the pre-trained policy. So we just use the pre-trained policy early on, and as the world model gets stronger, we just crank that down to 0. And that's a pretty small warm-up, 12% of steps. Action supervision RL policy updates, adding a model-based BC loss. No, this still isn't the detail I was looking for. Are they not sharing all the details of the design of the different components of the model? I feel like I don't know what Newt's basic architecture is. Right? Like, do I know how the state encoder is instantiated, or are they just not sharing it and that's why I'm not getting it? Sorry, these are the details that I tend to care about the most. Okay, here. Encoder dim is the dimensionality of each hidden layer. Okay, so we have a state encoder, but what exactly is the input to the state encoder? That's something that I'm confused about. So I can see that, like I can see the encoder dim, like these are the dims for the state encoder, but what is the input? I'm still missing that, right? Maybe if I spend a long time in the supplementary. I mean, I'm getting some more network architecture here. Now that I'm in, okay, implementation details, I guess that's where I always wanted to be. All learnable components in equation 1 are implemented as MLPs. The encoder H contains a variable number of layers depending on the architectural size, and we vary the number of Q functions in our ensemble when training larger, smaller models than our default of 20 million. MLPs consist of linear layers followed by layer norm and MISH activation functions, and the latent state representation is normalized using a simplicial embedding as originally proposed and applied to an RL context. We summarize the architecture using a PyTorch-like notation. Okay, so we have the state encoder, which is 3 linear layers, dynamics, 3 linear layers, reward, very similar 3 linear layers, policy prior, very similar 3 linear layers, and the Q functions is 15 linear layers. When the agent is conditioned on embedding image embeddings in addition to state and language, the encoder is expanded as follows. Some more linear layers. So lots of MLPs. So it's MLPs all the way through. And it looks like the agent Newt itself isn't ever like when it shows the images there, I suppose it's just trying to convey to us the state, right? I'm still confused about how the state input itself is structured. But again, this maybe is just a robotics detail that I don't know, right? They're explaining the simplicial embedding for people that don't know, like me. I guess we can learn real quick together what simplicial embedding is. Okay. Simple method for normalization of the latent representation Z by projecting into L fixed dimensions. Simplex. Simplices. Okay. Using a softmax operation, which is first applied in RL context by Hansen. A key benefit of embedding Z as simplices as opposed to discrete representation or squashing is that it naturally biases the representation towards sparsity without enforcing hard constraints. Yeah, I guess softmax will the softmax that they use not squash? I mean, let's look at how they implement it. Soft variant of the vector of categoricals approach to representation. Oh, they're just saying it's like an alternative to like one hot, basically, right? Like, sure, one hot would be this very hard forcing, whereas when you get a softmax, things are like, you know, if you had your I don't want to draw a simplex right now, but imagine we had a simplex. They're just saying like one hot, like snare encodings would be like you put it on here, here, or here, one of the vertices. But with the softmax, they can put it, you know, anywhere on the simplex, hypothetically. Which, if you do like the temperature right, it would make it sparse, and I suppose they do. But that's all this is saying, by the way. This is just a simplex embedding of the state, where V is the dimensionality of each simplex. So if you had corner here, corner here, corner here, that would be a 3-dim simplex, but you can obviously have like an 8-dim simplex by just imagining projecting like the first dim through the screen, that would be 4, and then eventually more dims than you can imagine, right? Okay, now I'm getting into details that are really probably too deep for most of us to care about, and really hard for me to even really understand. But zooming back out and looking at the paper at a high level, I think I'm a little bit better equipped to do that than I was. Which is we have an agent that's conditioned on language and can process the state, which I still don't know what the state input is, but sometimes also RGB frames that are dyno encoded, and they can jointly optimize it with online interaction across They can pre-train it on demonstrations in the supervised fashion while disabling the queue network, and then they can optimize it with online interaction across all tasks. And so I think the experiment that I want to see is going to suggest that my optimization on like task 200 is helping my performance on task 195. Or maybe at least that I get better performance on task 185 having trained on task 200 than if I used 1/200th of the total compute, right? I want to see that there's like some complementary interaction between these. So I will look for a figure that shows that. So this figure is just showing the average score for a single state-based agent on MMBench. They do. So keep in mind when we see the FastTD3 outperform them, like for Robodesk, that is like FastTD3 is already like kind of theirs, right? It looks like in general they're better than the TaskTD3 on these tasks. I don't know. I need to understand again what the single task BC is, because the single task BC might be answering exactly what I'm asking. I think that's just behavior cloning. Yeah, okay, so this is the important baseline. For people that don't know what behavior cloning is, the easiest way to explain it at a level that like just people that only know vision like me can understand is it's kind of like monkey see, monkey do. Like you can pick up the Xbox controller that controls your robot, and you can pick up the block a few times, or sometimes even one time, and the model learns to pick up blocks by copying you. And so they apparently compare against a language condition multitask BC as well as 200 single task BC policies. I'm not exactly sure how they're instantiating the BC still, even with looking at that. But if they do it properly, that is the perfect baseline, because that basically just says like take the single task, like the best thing we could do just having one task, and try to beat that with pre-training and then this multitask optimization. So I believe the gray is the way they explain that, like the gray is the language condition multitask BC policy, which is like kind of like the stupid baseline, but it's a good baseline for what they do, right? Because they're saying like let's compare it to like a stupid multitask thing, and then they're saying let's also take like the Oracle multitask, like what's the best behavior cloning can do when you just have to fit it to a given task, and then they're saying does our generalist tend to beat like the individual per task expert? And let's almost imagine that this blue line doesn't exist, right? And just look at the prior work, which is their adaptation on the FastTD3. And it looks like if you only had the prior works with their minor adaptation, you would often beat like the naive BC policy, but you would not beat like the optimized per task BC, right? Green is worse, that's 2 worse. Green is better, that's 1 better. Green is worse, so that's 1 to 3. This is like kind of a tie. This is losing, so that's 1 to 4, 2 to 4, 2 to 5, 2 to 6, 2 to 7. Okay, so it loses 7, ties on 1, beats on 2. That's the FastTD3, right? Whereas theirs beats on 1, 2, 3, 4. We call this a tie, so we'll call that a tie. Call this a tie, beats, tie, tie, loses. So it loses on 1, and it beats on several, and it ties on a few, right? So I'd say there's definitely makes a lot of progress in terms of this, like actually taking advantage of the massive training in the environment. Whereas if you use the naive BC, it's worse than the single task. And even if you use their improved FastTD3, it's worse. So I would say if we're trying to answer my question, which is does it work? It seems to work. Do I fully understand it? Not exactly. I think I understand like the broad concepts, right? Which is using this like joint embedding prediction to choose actions that are going to be optimal for our summed reward. We want to take favorable transitions, sure, but we also want to make sure we're approaching good terminal values. And we do that by having a model that can understand the language and understand the state and optionally understand the dynamics of the image. And it's not even that heavy, right? We saw the implementation, like they can do pretty well, even when this is a 3 million parameter MLP. This could be like a 3 million parameter MLP, I think. This is a 3 million, and then they have a few more other things for dynamics. It sums up to like 20 million parameters. I think that's the main model, so that's what we're seeing in these figures. Do we scale good? I'm kind of curious about that, actually. We can look at the model size ablations here. 80 million. Diminishing returns. There's a reason they picked 20, right? 80 million does not outperform 20, but 20 outperforms 5. MLPs aren't going to scale that well, though, so that's not super surprising. There may have been a better way to design the networks where they would benefit more from scale. Or maybe we're already kind of at the vanishing point of data, where you increase the model size, But when you increase the model size, your tokens per parameter goes down, so your scaling's worse, right? So that could be why you see diminishing returns. You're not actually model bottlenecked, you're data bottlenecked. Granted, the MLP should not follow the scaling law of the transformer, so once again, that's another reason why I'm kind of skeptical that this was the best way to design it, but hey, it works, and it shows a kind of a proof of concept for training an RL policy in this way. Environment steps, looks like we also, sorry, batch size. It looks like we found the optimal batch size for this configuration. That's fine, which is 512. Clip is better than, no, clip is pretty much same as just using task ID. But I think the task ID is like an oracle. So the clip performs as well as this like oracle, maybe learnable embedding on a task ID, which that's pretty cool. But maybe like a better model that could like provide information about the task, and that could do even better. I don't know. Demonstration. Is this just saying like less demos or less pre-train or less BC and just having all of them is better? What's that trying to say? Do I care, or have I spent enough time on this paper? Kind of care. This is like, here, let's see where they explain. Demonstrations improve performance. You find that any individual way of using demonstrations, pre-training, oversampling, model-based BC loss is helpful, but using them all in conjunction yields the best overall performance. Oh, this is pre-train only. This is behavior clone only. Those are the two like lighter blue lines, and then the gray is like demos only. But using all of them is the best. Okay, that's all that's saying. Okay, let's look at, sorry, I've been ignoring the chat a bit because I've been like way too focused on this paper. My bad. I will look at, Sam's tried to help me. I think the state is from the game code. It's literally just game state. Okay, sorry. I think I was imagining this being a robotics thing, Sam's, so much that I ignored the fact that it could literally just be like internals to the simulation of the game. So I suppose that exists in real robotics too, right? Like we maintain literally the position of the arm and like the observed positions of other things. That's probably the state. It's my bad for being dumb and just not thinking. Thank you so much. I should have read that sooner. That makes way more sense. Once again, robotics, not my core area or RL, right? So I'm liable to just forget these like super basic things. So sorry about that. It's 11 a.m. See you next weekend, Matt. I'm not done quite yet, Hassan. I think I'll grab a couple more papers. I was just giving people, better to undersell over deliver, right? Give you a decent warning before I get off. Really enjoyed. Thanks, Hassan. And if you're hopping off, that's fine too, right? No one has to, I don't take it for granted. No one has to sit here. I think it's crazy that there's 11 of you willing to sit here and just listen to me yap about papers. I think it's called RAM based as opposed to pixel based RL. Oh, is that what people are calling it? Sorry, what's the RAM standing for, Sam's, in this case? I don't think they're using this terminology. Just reward action model, is that? Yeah, what are they meaning with RAM? The inclusion of the language embedding is surprising. I asked the author about it, and they kind of admitted that the language prior is basically acting like a task ID. Yeah, I mean, that's what we see in the graph, right? I don't know when you sent that message relative to when I said it, but I feel like I sniped that pretty decently considering how dumb I am when it comes to this kind of thing. That the clip basically is going to give the task information. It helps a little bit with slightly out of domain generalization. Oh, really? Oh, random access memory. Oh, random access memory based RL? Are they calling it that in this? Here, find me a paper that uses that term, Sam. I kind of want to see, Sam's, I kind of want to see what exactly they mean by it. Are you just saying because we're using the state data only and we don't need pixel observations at all for some of these things? Is that what makes it random access memory RL? Because we don't necessarily need that DynaV2 or any image encoder? Or what makes them say that? What kind of projects would you recommend for okay, let me see. I think I lost a question up here. I'll go to that while Sam's maybe comes back to me with follow-up. So ideally, as a senior currently working in Jobin's lab, working on a paper, what are some metrics that I should try and meet if applying to a top PhD program UMD student? Metrics. You are working with a phenomenal advisor. Hopefully you're working with some of his phenomenal students, and you are a senior, right now a senior. A rising senior? I mean, if you're already a senior, then the application deadline passed for this cycle, right? If you're talking about you're gonna have a gap though, so you're applying like next cycle, I'm basically gonna pretend you're a junior, right? So let's assume that you can keep your cluster access if it turns out you're graduating, and that you can keep working on finishing this thing. I mean, you should hopefully, whatever you've been working on, you're targeting NeurIPS, right? Um, or iClear. Waiting all the way till CVPR would be pretty brutal because all you'd be able to say is paper under submission. And Jobin's letter will carry a fair amount of weight, but it would be much better if you can also have the work that kind of speaks to itself. There are other ways the work can speak for itself too, though. You know, even if it's submitted to CVPR, if you're able to get on an arXiv, get it on GitHub, if it can get some attention and some traction, then maybe the people that screen your application will have heard of the paper and that could be beneficial. But the main metric you want is you want to work on a high impact project. A high impact project that's going to come across well in your personal statement, where it'll become clear when you talk about it that you know what you're doing and you have demonstrated research potential. And that project will also come across well in Jobin's letter, where he's able to speak to your good research capability because it's been demonstrated on, you know, this decent project. It'll also give you good chances of acceptance to a top conference, which will be a really strong signal to be on your application. So if we're talking about metrics, it's first author paper, top conference, or the closest you can get to that. If you can't get top conference, second conference. If you can't get first author, second author, right? But the closer you get to that standard of first author, top conference, the more you have a chance of, if your letters are good and if your personal statement is convincing, you know, maybe having a shot to get into some program, right? Like I have my undergrad that I mentored, Ani, and I think he shared when he was on the, not the stream, but when we recorded the podcast style video, right? He was able to get, and actually since then he's gotten other offers, right? So with one first author top conference paper that was not accepted at the time of applications, but has been accepted since then, and some strong letters, he's been able to parlay that into acceptances at top programs. So I think that one top conference, top like first author paper is a great single metric. I hope that answers the question. If you meant something else, you'll have to clarify. What kind of projects would you recommend for undergraduate for upskilling, or like good, meaningful project, more of research side? Okay, Bahavia, it kind of depends on your starting point when it comes to upskilling. If you can't look at a paper in your chosen area of research and re-implement it, given ample time, then you need to learn how to do that, and that needs to be where you start. You need to be able to read a paper and be able to, for a good paper, translate it into implementation. That's really important. From there, upskilling your ability to create ideas is very hard. That's going to be like one of the later things that you're learning as you just get experience, right? But what you really want to learn, ideally with the help of a mentor, is how to get a good research problem, which ideally comes from the mentor, and then create a very nice tight feedback loop where you have a good idea relative to solving the problem. You think of meaningful things to try that can be tested and measured, and you take steps every single week towards that. Every week you have a thing that you're trying with respect to the broader goal. You have a way that you're measuring whether it works, and you're able to come back to your mentor every week or twice a week and say, this is what I tried, this is what happened, this is what I think we should do next, what do you think we should do next? And as you work with them for longer and longer, hopefully it becomes less of them having to tell you what to try next and more of you being able to come up with on your own what to try next. But getting the problem on your own is going to be really hard. That's where you really want to look for someone else. The main thing you need to focus on is just being accountable. And every week having a nice structured update with what you tried, knowing why you tried it, and being able to explain, you know, this is where it worked and this is where it failed. It's okay if you don't know what to do next. That's part of what the mentor's for. If you can just give them that continuous update showing real problems and or real progress, they should be able to help you close that feedback loop with real solutions, and you can just keep spinning, right? The key thing though is finding that mentor. Key thing is finding that mentor. I think the state is, okay, sorry, that was just from we're talking about the paper. What kind of projects would you recommend for undergraduate for upskilling, or like good meaningful projects more on research side? I think I just said mostly Bahavia. First start with the re-implementation. If you want to hear a really simple thing from me, you'll just have to tell me an area you want to do. If you don't know an area, I'd say something really, really easy is look at like the latest diffusion caching paper. Like, I don't know, like, is this one publicly available or not? Yeah, like this paper. Re-implement this paper. That's a starting point. Something concrete. And then from there, do your lit review, find a mentor, think of a way you can push the state of the art in diffusion caching forward. Easier said than done, right? If I had some great idea for diffusion caching right now, I'd have someone working on it. I had my nice idea. It got accepted to iClear. If you're going to be at iClear, go say hi to Ani. He'll be presenting our poster. But yeah. Okay. Rising Senior Muhammad. Oh, perfect. Rising Senior is perfect. Yeah. But like I said, that's the metric, let's say. as close as you can get to top conference first author paper, that's where you want to be as a metric. Brutal that I have to say that because it's hard. And I wish I could just tell you, just focus on the research and make sure it's high quality, but you asked for a metric, and that is unfortunately the metric. Yeah, it was popular back in 2010s, a short survey on memory-based reinforcement learning, Dhruv Ramani. Okay. And so you're saying we're just going back to that by showing that we don't necessarily need the pixel information at all, SAMs, in order to do good reinforcement learning? However, even after success in many domains, one of the major challenges is high magnitude of interactions with the environment. Seeking inspiration from the brain, the problem can be solved by incorporating instance-based learning by biasing the decision-making on the memories of higher-order experiences. Recent reinforcement learning methods incorporate external memory to solve decision-making. A survey of them is presented. Okay, I don't think I have the energy to go through this right now, but maybe another time. If you bring the paper up another time, I'm happy to go through and try to learn it. Maybe I need to learn more RL for the fans. Wait, no? Wrong paper? Okay, that didn't seem related to the random access idea, but it seemed like it would be helpful to me understanding modern RL a little bit. But yeah, I kind of wanted to go over this paper. I kind of wanted to look at this one. I kind of wanted to look at this one. Dang. What's good about this baseline or about this benchmark? Let me fit it to the window real quick. Hang on. Let's do literally 1 minute. If I can't get this in 1 minute, we're not getting it at all. A simple baseline for streaming video understanding. So they're going to, oh, a baseline. This isn't a benchmark. This is a method. With only 4 recent frames, oh, it's showing that you can answer tons of questions based on recency. But the thing is, OVO Bench is really biased to, like, all the questions in OVO Bench are based on the most recent thing. Like, it's basically like they give you the clue frames based on, like, where they give you the question in time with the video. So obviously you don't need to look at the longer frames. So this is basically just, like, talking about the fact that OVO Bench is flawed. We therefore argue future streaming benchmarks should separate recent scene perception from long-range memory so that performance improvements from added complexity can be evaluated more clearly. That's a great idea. It's already kind of been done. There's things like CV Bench that actually do require the longer understanding, like going further back. Even I think LV Bench is better than OVO Bench. Like OVO Bench is almost uniquely weak in the way that it requires this. But still, it's good to show this kind of thing. It reminds me of like 3 years ago when there were all those papers coming out that showed that you could outperform the video models of that time by just picking the right frame. And that you could pick the right frame just by sampling a few frames. And then once you had the right frame, you just use regular clip instead of video clip and you outperform video clip. This kind of reminds me of that. But it's not actually because the models are bad at video or anything. It's just because the benchmark are designed, like OVO Bench is designed in a super silly way. Okay. And this is really on my mind because I have had reviewers recently complaining about it, and it makes things not fun. Anyway, try attention. Efficient long reasoning with trigonometric KV compression. So maybe it's tri attention, right? Let's see if we can see what the method is. QK concentration and implications for attention. Pre-rope QK vectors of the dominant frequency band are highly concentrated. Rope rotation disperses the vectors into arc patterns, which is good. We don't want everything in the same spot. 3 distinct input sequences are overlaid showing the structure is stable across content. Okay, so this isn't like they just picked weird content, right? This concentration holds across nearly all heads, so it's not a head-specific thing. And when QK are concentrated, attention logics can be accurately reconstructed using a trigonometric series. Okay, so because there's this specific pattern of the concentration of the QK logits, they can reconstruct them with the trigonometric series, which means you don't actually need to have all the QK logits at all times. You can compress them and then reconstruct them when you need them, right? Is that going to be the main idea here? I assume. Post-rope compression methods, let's see. Pre-rope in the trigonometric series. So we evaluate QK distributions in pre-rope space. For each head, we identified its dominant frequency bands, the frequencies that contribute most to the attention logit, and what is the actual method. We use the mean resultant length, which measures how tightly the vectors concentrate around their mean. So we're modeling the distribution really well, and we approximate them by their centers. This approximation transforms the attention computation into a trigonometric series that depends only on QK distance, which means you can take the center and predict the attention patterns from the centers alone. So then what do they actually do? Though rope frequencies follow a geometric rather than harmonic progression, the principle is analogous to Fourier synthesis. The learned QK centers determine the coefficients, which in turn shape the attention versus distance curve. Different centers, different curves. Some peak at small distance, others at large distance, but the distance preference is encoded in the QK centers and can be predicted via the trigonometric series. So what are they actually going to test? They test whether it causes attention to follow the distance preferences described by the trigonometric series. So they compute the series from QK centers and check if it reconstructs actual attention. And what do they find? Let's see. So they compute the mean, Q, and K vectors from a calibration data set in the pre-rope space, and then plug them into the trigonometric series. And then, let's see, and substitute them into trigonometric series. And this yields a predicted attention curve over QK distance. To quantify the prediction quality, they define the reconstruction correlation between predicted and actual logits. Here, A is a vector of actual attention logits for query, and S is the predicted logits from equation 4. Yep, the predicted logits according to the trigonometric series. Both. Okay, so for the first head of the first layer, to avoid cherry picking, prediction closely tracks the actual tension with decent correlation. Across all heads in 3 different architectures, our peaks around 0.6 to 0.9 with mean values above 0.5. Okay. The high correlation across many heads confirms that the trigonometric series computed from QK centers accurately predicts attention patterns. We find that QK concentration is model intrinsic on Quen 3.8b, measuring MRL across math, coding, and chat domains yielding nearly identical values, with 90% of heads exhibiting R greater than 0.95 regardless of the domain. It holds across all architectures, including MLA. Okay, that's important, I guess. So they propose a QK cache compression method that scores key importance and retains only the top scoring keys. The scoring function combines the 2 signals, the trigonometric series, which captures distance preferences and norm information as a complement. The weight between them is adjusted based on QK concentration. Finally, we describe how to apply the scoring for KV cache pruning. Okay, so the keys are already cached. Let's zoom in. Okay, like K, so we're talking about pre-rope of key K in frequency band F, and then the delta is the QK distance. So keys at different positions have different distances to future queries. To estimate how much attention each key will receive, we use the Q center as a proxy for future queries, justified by the QK concentration observed in 3. The trigonometric series then gives the expected attention at distance delta. So we get the Q center in the frequency band F, computed from the calibration data. Since keys in the cache are known, we can directly use the representation K, their pre-rope representation, to be clear. The phase of the expectation on Q sub F, which is probably our pre-rope Q, right? Yeah, just our pre-rope Q, our pre-rope query, is the Q center in the frequency band F, computed from calibration data. Since keys in the cache are known, we can directly use the representation K. The phase is the angular difference between the Q center and the current key. The trigonometric series assumes QK are exactly at their centers. In practice, there is variation around the centers, and this variation affects attention. We account for this as a norm-based term. Ooh. Here, the expectation on the set is the expected query norm in band F, which is computed based on the Q center in the frequency band, which is computed again from the calibration data. Unlike methods that only consider K, we weight each frequency band by its expected query contribution. Okay. So we're able to compute this expected query contribution because the calibration data gives us these Q centers that are pretty stable within a given layer across actual inputs. Adaptive weighting via concentration. The trigonometric series is most accurate when Q, K are highly concentrated. The norm-based score S norm becomes more important for the few heads where concentration is lower. Okay, so this S norm, which uses our calibration data and our actual keys, is going to be really important when the concentration, like when the K and the Q are not as concentrated. Okay. We automatically balance these components using QK concentrations. Oh, so we measure the concentration and we rebalance them with the weighting factor because the concentration, we quantified it with the mean resultant length. Since we have that concentrated, we can just basically, like, the longer the mean resultant length is, the less of this correction factor based on our like prior calibrated knowledge we need to use, right? What is this? What am I missing here? Is this a, oh, wait, no, Sorry, I feel like I'm blind to this. I feel like I'm looking at, oh, it's just the, okay. It's the Q center minus the mean resultant, like not the mean resultant length, but specifically um, the query. Wait, no. Hold on. We just take the expected query norm divided by, hold on. Sorry. I totally lost my train of thought. Wow. Um, okay. Basically, we're reweighting based on the frequency band. So, like for ones that are more concentrated, we are going to use for ones that are more concentrated, which means lower R, we are going to use more of this? What? Right? Lower R means we're using even more of our... Oh, because it's most accurate when QK norms are highly concentrated. And the norm-based score becomes more important for the few heads where concentration is lower. So when the concentration is lower, R is bigger. What? Okay, I'm still a little confused by this argument. The norm-based score becomes more important for the few heads where concentration is lower. You automatically balance these components using QK concentration as a weighting factor. Because the S norm is just going to be bigger when R is small, right? Wait, no, the S norm is going to be bigger when R is small and it's highly concentrated, so that's going to make the S norm bigger. It says it's more important though when it's when the concentration is lower. When the concentration is lower, no, when the concentration is lower, R is bigger. Then it says it's more important, but it looks like it'll be smaller. So I'm a little confused. When R is, the concentration is strong when R is high. Oh, wait, what? Okay, so the concentration is small when R is high. I thought, yo, what's happening here, GameX? What's happening here is we are reading this paper on basically a way to compress the KV cache based on a phenomenon in the attention where our pre-rope K and V are highly concentrated, but we can predict pretty reasonably where they end up with after rope. With this trigonometric series is what they proved in section 3. And now we are using that understanding to basically retain like a set of the most important keys, which are going to correct based on like attributes of the queries that we learn via calibration. Like basically we can learn this distribution based on calibration data, and then it's pretty consistent no matter what the prompt is. That's what you're seeing here. Actually, they've used multiple sequences. So no matter what the input to the model is, those end up being pretty consistent. So if we can learn this Q distribution beforehand, and we can use it like combined with our kept important keys pre-rope, in order to basically not need as many of our actual keys and values in the cache. Let's see. Yeah, let's look at how they're actually doing the pruning. Okay, so with the scoring function, which, let's see. They're defining a scoring function here. So the scoring function is, this is used as a scoring function. Okay, so the final scoring function is strig, which is here, which is defined by the geometric series, plus S norm. And based on the scoring function, let's see. We score each key in the cache independently and retain only the top. So we're going to retain the highest scoring keys according to the trigonometric series and the normalization based on our prior knowledge combined with the current keys, right? Our prior knowledge in the query combined with the current key. Before selection, we address two practical considerations: reducing the computational overhead of scoring and handling group query attention where multiple query heads share each KV head. We're not going to look at the GQA specific details because that'll get really complicated. But for the window-based pruning, at least scoring all keys at every decoding step is very expensive, so instead we trigger pruning every 128 tokens. When the 128th token of each interval is generated, if the catch exceeds budget B, we score all keys, retain the top B, and evict the rest. So every 128 token interval is a window. Okay, so yeah, we basically don't constantly eject keys. Every 128 tokens will go through and we'll eject keys to retain the top B. And we retain the top B based on this matching between how much they match with whatever we measure these Q centers to be, as well as whatever they indicate based on the expected attention at distance delta. So we're basically trying to like maximize the informativeness of the keys that we're keeping in the cache by seeing which ones of them are giving like the highest expected attention. Does that make sense? So it's like we're taking like whatever our current input is, we're looking at the most informative keys basically by two different strategies. One of them is the trigonometric series, and the other is just this correction based on sort of this like global query knowledge. And I think the idea of this, well, they say that the idea of this is that there's some heads where the concentration is lower. I assume the head where the concentration is lower are the heads that are like a little bit more sensitive to whatever the current particular prompt is. So that's why the concentration is not as high. They kind of spread out more and they'll shift more and be more sensitive to the specific nature of the current query. And so for those, we have like a learned prior based on the overall distance of queries across like a lot of prompts. But that's what we're trying to correct for. So when the concentration is high, S-norm doesn't do much because we know that the concentration is pretty high for that head, so we know that it's pretty stable. And we know that we can evict pretty safely just based on the importance of the current thing. But when the head changes a lot, maybe we keep some of that prior information more, or rather we use a more global approach, the S-norm, to keeping those keys so that we don't just like evict them willy-nilly. That's like my hand-wavy intuition, I think, for what's going on here. And they are, let's see, all methods are compared to the same KV cache budget, so full attention obviously drops the results compared to full attention, but I don't know. I want to see some stuff where they compare the budget. Like how much can I prune my KV cache and retain decent performance? I want to see like a Pareto frontier or something, right? Here we go. Pareto frontiers. KV cache budget. So full attention. Oh, that's a little weird. We can like kind of beat the full attention occasionally, even with a decent budget, right? What is the KV? What's the equivalent KV cache budget of the full attention? I'd kind of like to know. But anyway, it looks like it depends on the task. Like tasks where the accuracy is higher in the first place it looks like we are able to go down to like 1K budget and still have good performance. Whereas like it starts dropping immediately on some of these harder tasks. Oh, and it looks like prior works are going to deeper recursion requires retaining more intermediate states, increasing memory pressure. Interesting. I don't really know what that memory retention benchmark means, but the stream's getting pretty late and I think I'm kind of done with this paper for now. It's an interesting idea. I feel like I need to spend some time to really understand, like I don't have background to know exactly what this trigonometric series is, the one defined here. I'd want to like plot that and see it, and then maybe I'd understand that part a little bit better. I also feel like I understand what they've plotted here, but I don't exactly understand all the reasons and all the implications, so that would take more time too. But I think I got what I want for now, so I think I'll close that. Sounds interesting, although it's very complicated for me to understand. Yeah, GameX dude, it's the kind of thing where you just need to spend more time on it, I think, including me. Should I do a PhD ML if my main motivator is the research scientist salary? Hamayun, that's a great question. I meant to talk about it in the stream too. I think as the salaries inflate a lot in AI, we get a lot of people that before would have tried to do like quant or business or like some other thing, which has created kind of a cultural shift and not necessarily a good one. Two tricky things to keep in mind when you're talking about doing it if the main motivation is the salary. One thing is you're going to be competing against a lot of people that like really want to do it. And you'll always be talking about things like burnout, whereas like that's not even going to be like vaguely on their minds, right? Like you're going to be competing with a lot of people where this is genuinely their hobby and like the only thing they want to do. That's going to be pretty hard. So you're going to have to work hard against people that like the thing better than you. The other thing to keep in mind is it's really hard to predict if the salaries are as good in 5 years as they are now. Even if the technology gets better, there can just be other pressures that push the wages down, so you never know. And so it would kind of suck just to throw 5 years in if you're just hoping for the pot of gold and then the pot of gold disappears. I'm never going to dissuade someone from looking at salary data and just trying to study something accordingly, though. That's a reasonable thing to do. A PhD is a very difficult thing to do, though, when that's your motivation, because you're just not making very much money for quite a while you wait to eventually hopefully make the money, assuming that the market stays strong by the time you're done. Anyway, that catches me up on questions. I kind of wanted to do this one more paper. Maybe I will since it's open, and I already trimmed it for my thing. I need to go to the bathroom super bad though. So this is definitely the last one, and then I'll look at questions, and then I'm closing the stream. So get your last questions in now. This is the real final call, because I gotta use the bathroom. Think in strokes, not pixels. Process-driven image generation via interleaved reasoning. So humans paint images incrementally, global, then coarse and spec. Sure, that actually sounds like diffusion, by the way. However, can unified multimodal models trained on text-image interleaved datasets also imagine a chain of intermediate states? So a process-driven image generation, which is a multi-step paradigm that decomposes synthesis into a reasoning trajectory of thoughts and actions instead of joining images in one step, where, oh, sure, we'd give tokens, and then the diffusion model would decode those tokens, right? So that's one step for the model that's doing the token prediction, many steps for the diffusion, but they're talking about the prediction of those tokens, right? So they're basically talking about chain of thought, I think, for the image generation. Each consists of 4 stages: textual planning, visual drafting, text reflection, visual refinement. This makes me think they're going to do like a text-only stage, and then generate an initial image, and then one more text stage, and then generate one more image, which is fine, but it's not like, I'm not mind blown, right? Yeah, so we're going to generate text, and then we're going to generate an image, then we're going to look at the image, and then we're going to maybe do some more planning inspection. So we can do, it looks like they can chain refinement steps, right? So we take a first image and we just sort of iterate on it, and we probably continually like, yeah, you can see, I think the sketch here is the input here, right? So we generate the sketch, and then we feed the sketch along with like whatever the model's saying. But the thing is, the model is the one reasoning on this, right? It's not like we're prompting it, aside from like telling it to create the image step by step and designing this framework. So the model generates the plan. The model then sketches the image according to the plan and says, maybe based on seeing the image, what it wants to do next. And based on that, we do that. And then based on that, we plan something. And then, we keep iterating until we have our final image. And we know we have our final image, and the model says it's done. And I guess you're going to need to tune parts of the model. It looks like they're saying for some reason we need to tune the vision start and the end of sequence again. I don't know why, because this is a unified multimodal model that probably could already process interleaved image text. It's a decent idea. It's a bit like tightly regulated, but I also like it because it gives us an actual reason to do interleaved image text, which I don't feel like you see in a lot of other models. I complained about this before, where when we see these benchmarks, it's always like, oh yeah, here's the generation benchmark, here's the reasoning benchmark. This actually combines the generation and reasoning into like a unified thing, which I think is neat, all things considered. I think I understand this well enough. Construct prompts, sure. Our prompts are from graph structure, so we have complicated prompts, sure. To justify it, you do need hard prompts. They're explaining how they get hard prompts. What benchmark is this? Genival? Genival 1 or 2? Can I tell based on the scores? Yeah, it's Genival 1, I guess. They get better scores, and they take Bagel and they just tune it, right? What parts were tuned again? Is it an RL wrapper? Is it an SFT? Is it a little LoRa? It's not clear to me. Do we just tune these vision start tokens? Is that how we tune? LoRa. Fine tune. Fine tune Bagel. How do we fine tune it? All the model parameters are fine tuned end to end, 8 H100s for 10,000 steps using a pack sequence of 33,000 tokens, higher learning rate than I would think, and a cosine decay. We extend the original training objective to support seamless transitions between textual reasoning and visual generation with a single autoregressive sequence. At inference time, when encounter vision start, the model seamlessly switches to image generation mode to generate visual aids. The entire interleaved generation process only stops if the model generates the vision end without vision start following. That's how it transitions between the steps, like between the sketch and then the refine and then the plan and whatever. Okay, cool. They fine tune it. This isn't from ByteDance though, is it? No, it's from Meta. An internship at MSL, actually. Interesting. Okay, think we understood that one. I'll see if any of you all have questions about anything, and then I will end the stream. This was a decent one. How difficult is it to get to DeepMind? Very difficult. It's very prestigious, and in my experience, people like working there so much that a lot of people take pay cuts to work there. So you're competing against the top scientists in the world, and then once you finally get there, you're typically taking less money than you would elsewhere. but everyone that I know that is there really, really, really loves it, and a lot of them never ever leave ever. Um, I think a lot of people really like that it feels like Google has that coherent vision, right? Where it's like they've really chased a few specific things. I guess you could say maybe it's not coherent. Now, what about like Google Health? What about like Google's Graveyard? But I think I mean like when it felt like Meta was really chasing like AR, VR, every and AI and like every shiny thing under the sun. It did feel like Google made a little bit more concerted effort to focus on AI and then AI applications, like AI application to health, AI application to self-driving, AI application to video compression. Um, and so I think a lot of people like the leadership, they like the ethos, whatever. Very, very competitive. I think no matter how well their current model's performing, they will always be considered on the same tier as the frontier labs, even if they don't give compensation at the same level as the frontier labs. Sounds good, thank you. I would say I am generally passionate for AI research, but nowhere near the level of others. I wouldn't compare yourself too much on that. I mean, you have to know, Hamayun, like, and be honest with yourself about your motivation, but like, you don't have to be the most passionate person in the world, right? You just have to have a passion and work consistent and try to be smart about it. Are there works on using INRs for multimodal fusion? One example would be fusing LiDAR and camera data. Yeah, there's definitely multi-signal INR. I've definitely seen a few in like workshops and stuff. Nothing super crazy comes to mind. I saw someone once use it for like geospatial data. Um, and so they're fusing lots of modalities there. So you can do multimodal. Nothing super specific comes to mind though. Wait a minute, who are you and what's happening, guys? What's the live about? Hey Rakesh, you're coming in right at the end. I'm answering last questions before I go offline. I go live every week, 9 a.m. Pacific time. We read papers. I answer everyone's questions. Questions about PhD, questions about AI, questions about research, questions about life. Um, and reading the papers is sort of a backdrop for it all. And just a nice thing to do to try to keep up with what's happening in research. But anyway, that's it for me for today. Thanks, everybody. Do you think it's about time Google will catch up in AI training hardwares as well? I think Google arguably is already ahead in some sense in AI training hardwares, right? Like TPUs are pretty powerful. They own their own hardware stack. That's a pretty big advantage. And every time they release a model, it seems really strong. Gemma already has more downloads than the latest Xiaomi had in its first 7 days. So, I mean, Google's right there with all the big dogs, right? Maybe they don't have the best wrapper like Anthropic, or maybe they've got a lot more things going on than some of those companies, but all the things they do are very, very, very strong. Anyway, take care. Yep, come next time, Rakesh. It's a good time. We try to keep the community nice. It would be nice too if people feel comfortable interacting in chat, recommending papers to each other, answering each other's questions. I try to answer them as well. Anyway, till next week.